We are streaming live. We are streaming.
Hello, everyone. Welcome to day 2 of our FreeBSD Developer Summit for the summer of 2021. We have an exciting schedule today. First off, we're going to have a talk from Einar, who works with the Icelandic DNS registry. After that, we have a couple of working groups, actually 3 different working groups, one of which is Warner's session he talked about yesterday involving workflows. We're going to see if we can fit that into a half hour or not. Finally, towards the end of our day, we're going to have a 14.0 planning session, which is going to be an interactive session, kind of like a have, need, want type session that we've done at Dev Summits in the past. So you're definitely going to want to be around and on chat for that. And then finally, today, we're going to close with a session of short talks that we call work in progress sessions. If you are interested in giving a work in progress session talk, we can still add these pretty much right up until about the time that WIPs start. There's a table on the wiki page for the Dev Summit that you can go add yourself to. For WIPs, we are looking for a talk that's about in the range of 5 to 10 minutes. You don't have to bring slides unless you really want to. And we'll just do that on the webinar at around 12 noon Pacific on our schedule. So that's about all I have. Oh, and another reminder, we do have a survey that we will be posting we'll give you the link tomorrow to kind of get a thought for your experiences for how this Dev Summit is going. So keep in mind what things are working and what things are not. Also, please join the hallway track if you have it. We had a lot of fun activity. I know I hop over there during the breaks. So if you want to talk about stuff or continue conversations that we couldn't quite fit into a time slot, the hallway track is a great place to do that. So our first talk for today, as I mentioned, is Einar. So I'm going to turn it over to Einar.
So, can you hear me?
Yes.
Yeah. And are my slides showing?
Not yet.
Not yet, no. That figures.
But I do like the picture of the whale on your wall.
Yeah, I thought you would.
All right, yes, we see your slides.
All right. We go back. As you said, my name is Einar. I'm the CTO for Icelandic, which is the DNS registry for .is in Iceland. And we've been using FreeBSD here from the beginning, at least 20 years. And today I'm gonna briefly talk about how we use FreeBSD and how we've done in the past and what we're looking forward to in the future. The company Icelandic was founded in 1995, but the origins go back at least to 86. There was an organization called Suris that was kind of the birth of the internet in Iceland, the first IP connection, the first international IP connection. And then in 1988, the .is was delegated to Suris. But in 95, they incorporated into Icelandic, which was then privatized in 2000. We have around 78,000 registered domains today. And we are an open registry. So registrant can come to us and register domains directly and transfer domains. And we have no registrars, which makes us, well, almost unique in the DNS world. But this may change in the future, but that's how it is today. And that also means that not only do we have to have services for registrars, we also have front ends for customers, and we have to help and customers with their problems. We've been using FreeBSD for over 20 years, and one of our oldest employees, he sent me a list. It was the oldest list he had. He was from 99 over servers. At that time, there were 10 servers. Today, we are running most things on virtual machines, and we are around 100 virtual machines today. We try to deploy single service servers instead of, in the old days, we deployed many services on each server. We are all self-hosted except for external monitoring, and we have domain hosting. So domain hosting for second level domains. They are hosted on cloud servers around the world. We have our own we have one data center here in Reykjavik, and then we are co-located in another data center in Reykjavik as well, which is our backup data center. We are of course, quite small registry, 3 developers and 3 ops. And in the last 2 years or so, we've changed our workflow dramatically. We have increased automation. We started using infrastructure as code and better monitoring. And when this was happening, it was all hands on deck. So developers, operators, we all came together, started writing Ansible playbooks. So we've been kind of breaking down the walls between developers and operators. And so if something needs to be done, we all just pitch in and everybody works together. This has worked very well for us. And this is something we're going to keep doing in the future. These are kind of the major services we are running. Of course, DNS. We're using bind for authoritative servers, unbound for resolvers, and currently using OpenDNSSEC for DNSSEC signing, but we are replacing that with not DNS in the near future. Our web servers running Apache and PHP FPM. Our EPP server is in-house, written in Java. We have multiple PostgreSQL databases, and we use HA proxy for reverse proxy and load balancing. And of course, we have many, many other services, but those are kind of the major services. Today, our workflow and how we use FreeBSD, we currently have Ansible playbooks that actually deploy our virtual machines, install the operating system, and configure the services. We might be looking into pre-built images in the future for faster deployments. I will get into it on a later slide, how actually this process works, but we are basically installing the operating system when we are deploying. So it's a couple of minutes. We have a dedicated Podria server, which builds our packages. We attempted to build the whole ports collection, and that obviously was not going to work for us. So now we have a package list that we use, and using Ccache and other things, it works very well for us. We have a Git repo where we clone the ports, and we add our local patches there, and usually we merge them upstream very quickly. The migration to Git has made this much easier for us rather than working with Subversion. We always prefer to use ports, and usually it works without problems. Means we can use just package upgrade to upgrade, and we can use package audit in an automatic way to let us know if there are known vulnerabilities. We are also using CFS. Our upgrade playbooks do a snapshot, a rolling snapshot of 5 last upgrades. We'll take a snapshot and then we do the upgrade. Makes it easier for us to roll back. This is probably not very popular, but the things that are not FreeBSD today and the reasons for it, our virtual environment is running on Proxmox using Ceph for shared storage. We've been using it for a few years, and it works very well for us. We haven't really looked into using FreeBSD for virtual environments. We're running GitLab in-house for our DevOps platform, and running it on Debian with the Omnibus package makes it easier. GitLab is big, and can be difficult to upgrade. So we chose the path of using Debian. Our phone system, the PBX, is running Asterisk on Fedora. Since our desktop phones, you need a binary module to work. They won't work with vanilla Asterisk. We probably wouldn't have bought those phones if we knew at the time. And then we are running Sential as our directory servers for Active Directory and Radius. We always look to use open source software. Basically, the only exceptions are our business ERP software, since invoices have to be generated by a software audited by RISC-V, the Icelandic tax revenue. And last I knew, no open source software was on that list. And then we have physical access control. I have yet to see physical access control that can be used with open source controllers. So we have to have Windows for that. Our networking hardware is mostly Juniper and Cisco. And then we have some Mac OS X desktops. Our tech people, devs and ops, usually run either, I think they all run Linux. But the software we use, if it's not in ports, we usually try to add it. And we have some ports already which are maintained by us. This is our deploy process, where we have a Git repo with Ansible playbooks and roles. Now, the first time the playbook runs, it provisions a VM and creates an ISO with an installer config generated by Ansible, and that is pushed to Proxmox, started up, and that installs the operating system, and then Ansible finishes configuring it. It works very well, but as you can imagine, it takes some time since it's doing an installation every time we deploy a VM. So we might look into ways to shorten that, but it works. Small updates to configurations are pushed to Git and the playbook runs. And so we don't deploy the VM every time. But major updates, then we can do redeployments, just shut down the old server and deploy a new one. All our playbooks run from a single master, and there are some pipelines running in GitLab that run Ansible playbooks. In the future, we have a big project which is deploying new signers and name servers for the .is domain. We are going to replace OpenDNSSEC with NotDNS. And we're going to replace Solaris running on an old Spark server with FreeBSD running on x86. And we are going to set up redundant signers in separate data centers. This is not an easy project. It's complicated, and we're doing it very slowly, but we are slowly getting there. We want to do more redeployments instead of updating servers. So even for small updates, we want to get to a place where we just destroy the old server and deploy a new one. We might look into using jails for that. I've looked at using Ansible to manage jails, but it is different to how we do it today. And we might also look at doing pre-built images with something like Packer. So our pipelines in GitLab could generate pre-built images for us, and the Ansible playbooks are very short, just installing the new images. We want to get more structure around the way we use Ansible, getting more of it into pipelines in GitLab, so it can be better audited and access controlled. So that was kind of our highlights. I'm sure there are questions. See?
So we have one question I've got on IRC,
Yeah.
which someone asked, do you know about seeded packages for Perdre? Which I don't know about seeded packages. So I might ask him for more clarification about what that means. But is that a topic you're familiar with?
No, I'm not familiar with seeded packages.
Okay, I'm going to try to find out more of what that is about, and then I'll ask a better question once I do.
Yeah. Until there are questions, I can tell you that one of the biggest problems we have in our day-to-day are in packages with dependency management. For instance, now the upgrade from Python 3.7 to 3.8, it causes problems sometimes. And we try to work around it, but that's that's kind of a pain point for us. I hope there'll be a better way to deal with dependencies like that.
So I got a little more feedback, I guess, and I don't know how it will fit into your workflow, but apparently seeded packages is the idea of using pre-built FreeBSD.org packages for things that you're using that are local and not modified, and only adding, kind of having that as a initial repository, and you just build additional things on top of that.
Okay.
So
okay. So the packages from the FreeBSD repo, and then just adding your local packages.
yes, and in particular, when you're building your local packages in Padre, it can pull from the stock packages for dependencies, so you don't have to build the full tree. You're only building the ones that you have different options for, or the ones that are local ports.
Yeah. Okay. All right. Yeah. At the moment, Padre is running fine for us. I think we have at the moment we have 3 builders. One of them is just for testing, and around I think 3,000 packages, and it's not causing us any problems. There are certain ports like we're still building Chromium, which often seems to cause problems. But even big ports like LLVM or Rust or anything like that, using C catch makes it a non-issue.
So another question I had from IRC is, have you looked at using any wrappers around jail, such as Bastille BSD or IOCage or something like that?
No, we haven't. I've seen 2 tutorials. One was for deploying a jail server, and one was managing jails with the SSH jails connector. But I haven't gone looking at it since then. But I can imagine with Bastille, it could become interesting again. Our current workflow actually works. This will make it could give us an opportunities, but it's not something that we're desperate to do.
Okay. Another question from IRC is, do you have plans to change your name server from bind to, what is the name of this one? NSD, which I guess is a name server written at NLNet?
The NSD.
Yes.
No, we did run NSD in the past, but a few years ago we migrated all of them to bind. There are no plans to migrate them away from bind, but since we're going to start using not DNS for DNSSEC signing, I think that would be the way to go if we were looking at moving away from bind.
Okay. Another question someone asked is, why did you pick FreeBSD 20 years ago when you started?
I wasn't here at the time, but Marius, who was at the time, he told me that the main reason was the quality of the network stack, which figures since he's a network engineer. And since then, today, I think the main reason is, besides the network stack, is the simplicity of it. It is we like things which are simple, and we have seen how most Linux distros today are becoming increasingly complicated with systemd services. So I think those 2 things are the main thing which are appealing to us.
Is there anything that would be helpful for you or that you would like to see in FreeBSD going forward?
I already mentioned better package dependency management, and some of my colleague actually told me to mention that he would like to see package space, and there was something else he mentioned, which I don't remember quite at the moment. But he was looking forward to package space. Myself, I'm quite on the fence about it. I like it. I kind of like it as it is. A very clear separation of base and packages.
So another question that came in is, do you have any plans to move any of your services either off of FreeBSD, excuse me, or onto FreeBSD? Related, I had another person ask why you aren't currently using FreeBSD to host GitLab.
Yeah, I answer the GitLab question first. That was the main reason was the complexity of GitLab and the high GitLab releases upgrades quite frequently, and their omnibus packages on Debian, the upgrade scripts there handle migrations and upgrades very well, which minimizes work for us. The port in FreeBSD, that would mean a lot of manual or labor from us to ensure smooth upgrades. But the other services which are not running on FreeBSD today, I think our PBX, the asterisk server, would be the next one if we can find a way to use the Digium module on FreeBSD. It is a Linux binary module from Digium. I haven't seen if it can be used on FreeBSD, but hopefully.
So I have a couple more questions about DNS servers. I guess some folks are really curious about using Bind. One question is, did you consider Power DNS, I guess, as an alternative to Bind?
No, Power DNS has never seriously been considered. There hasn't been for quite a long time any serious discussion about changing DNS servers. When we were using NSD, we were using NSD for authoritative servers for some services, Bind as a recursive resolver for some services and authoritative for some services. And at the moment, it was decided that we would just consolidate and use Bind for all authoritative servers and then Unbound for resolvers.
Okay, I think that answered the other question someone had, which was why you went from NSD to Bind, but it sounds like just consolidated on a single one, just to be simpler.
I'm getting a message from my colleague here. The thing he wants to see in FreeBSD is KASLR, the kernel address space layout randomizer.
So maybe that's something we can bring up in the 14.0 session to see who other folks who may or may not be interested in that.
Mm-hmm.
Okay, well, I've looked around. I don't see any other questions at the moment. So thank you very much for your talk, Einar. So
Yeah.
now, folks, we'll move on to our first break of the day, and we'll hang out for about 15 minutes, and then we'll come back and have our first working group session, which is going to be on the topic of boot code. That'll be hosted by Alan Jude.
Thank you very much.
Thanks, Einar. Okay, welcome back from our break, everyone. Up next, we have a working group session focused on bootloader code improvements, and that's chaired by Alan Jude. So I'm going to turn it over to Alan.
Right, are you seeing the slides properly?
Yes.
Good. Okay. The goal today was just to talk about the current status of the boot code and where some of the weak points are, and figure out how to solve those and where else we want to go with the boot code, and how we want to improve it over the near term and the long term. So I've kind of broken the presentation or our time down into a couple of things. The first being the update mechanism for the boot code. Now that we've moved to having the ESP actually be mounted in FreeBSD 13, that makes updating it a less of a manual affair. But compared to in the past, where you just used gpart boot code and treated it like the other boot code, and we're just slapping this image of a partition over top, it's maybe a bit more involved. But we want to figure out what the right way to do that is, and make sure that there are good instructions to follow and that it works for the very large majority of people. And that brings up my kind of second topic of choice for this one, was figuring out a fail-safe mechanism for boot code, or a fallback mechanism, so that if you do update your boot code and the new boot code doesn't work, you don't end up with an unusable system. Having some kind of mechanism to be able to fall back, whether that's just installing it as an extra option and it ends up showing up in your EFI BIOS as, just try the old boot code or something, or if it can be completely automated, which obviously would be preferred, especially in the remote server case and things like that. Then another recent thing that came up was, as part of the switch to OpenZFS, the instructions that come up when you run zpool upgrade reminding you to update your boot code went away. Those instructions were bad and needed to go away, but the loss of that reminder is maybe slightly suboptimal. And so there's been an effort to revive that, but I think the best thing there would be having a link to the section of the handbook that describes how to update the boot code, and someone would have to write that first before we can link to it in the OpenZFS source code. Then I'll highlight some work done by Colin Percival and Mitchell Horn on boot performance, both measuring it and improving it. And then we'll talk a bit more about where else we'd like to go with the boot code and what else we'd like to add. And then we'd also like to spend a little bit of time talking about testing and QA and CI for boot code and what we can do there. And then hopefully other people have things they want to talk about, or questions that we can answer. So first, obviously, they making it, why? Okay. These aren't supposed to be animated. My apologies. So right now, there's quite a few different ways you end up booting, which is, not necessarily what we would like, but it's a fact of life at this point that most systems nowadays, because of the way the installer was built, have a GPT partitioning scheme, and they actually have both the legacy and EFI boot code installed by default, because that's most likely to work on every machine. But that was one of the reasons why the instructions given by ZFS, which were from back in the day where it was GPT legacy and nobody used EFI, and it resulted in quite a few people accidentally overwriting their EFI system partition with the BIOS boot code. And that would cause their system not to boot anymore. And that would result in unhappiness. So most disks will have one of these 5 configurations. And if we're going to build an automated tool to update your boot code, it's going to have to be able to properly detect which of these 5 you have, and then figure out what the right thing to do is, which could be interesting in the case of the both option, where we can look at the sysctl like mockdep.boot method and figure out which one you booted with, but is it safer to update both if you have both, rather than having a second boot option that's becoming stale over time? So coming up with an updater for the boot code. In particular, ZFS is the main driver behind this. In the past, with UFS, the boot code generally didn't change very much, if at all. And so it wasn't a regular part of people's updating routine to worry about updating the boot code, because all it did was have just enough UFS knowledge to be able to load the loader, or the loader to load the kernel and boot it, and that's all you really cared about. With ZFS, there are constantly new on-disk format features coming, and these require that the bootloader understand those in order to be able to boot from that pool. And so we, on a regular basis, have to update the boot code in order to deal with that. The only other real option there is to do what Ubuntu and some other distros have done, of having one pool for the root file system that uses basically no ZFS features and is meant to be backwards compatible with 10 years ago, and then have a second pool where you put your more important files and they can use the ZFS features. But that really takes away a lot of the advantage of having boot environments and so on. And so we have updated boot code that can boot the latest and greatest ZFS features, but you do have to install it before you can boot from that newer version. And so that's led to frequently having to update your boot code. And we've not still to this point come up with a very good way to do that. In the legacy case, it's pretty straightforward, just with the gpart bootcode command, but it's not as seamless as hopefully it could be. Does Warner want to join in? I'd love to not do this alone.
I've been chomping at the bit to say something for a little while now.
I just saw your video.
I actually wrote an install boot script years ago to test the bootloader, so that touches on two of the issues here. It's been in the tree for ages. I've been trying to get traction for about 3 years for people to have an install boot, that section of like you have install world and install kernel, you have install boot. And in the case of using as part of the upgrading process, it's just a thin wrapper around a script that does this. One of the things is that's really needed here is like you said, knowing what exactly to upgrade. And I think some of that, at least initially, will need to be you're do as you're told, unless we have like a ---- dwim flag. By default, we should not guess at what's going on, because we will guess wrong. You have a 13.0 USB stick in your system, or a 12.0, and we don't want to upgrade that automatically, for example.
Yeah, or the whole point of the ESP is that it can contain the bootloaders for a bunch of different operating systems, and we don't want to muck up the other ones. Or
we've got, okay, then we use EFI Boot Manager, which I wrote a number of years ago, and you can easily select that. Now, Supermicro has issues with that. You can do a couple of OSs, but not a lot. And others sometimes just drop the persistent stuff. But there is a set of protocols that we can follow. We've registered EFI FreeBSD. That's why we installed the bootloader in EFI FreeBSD bootloader, so that we can create a boot environment variable, not a ZFS boot environment, sorry, a boot UEFI environment variable, so that we can boot off of that by default, with a fallback to the default one, which
according
to the spec was only supposed to be used for
removable
media, but according to reality is the universal fallback. Yeah. Windows installs its own and creates boot environment variables. So at least one is always there. Mm-hmm. But sometimes more than one can be difficult. With Linux, sometimes two is doable. But we should be looking at the standard things and having some kind of fallback or some kind of recommended port for something like refined to cope with the situations where your BIOS sucks, and rather than having it suck to be you, you can you can do that.
Yeah, having a port of Refine that actually installs itself and sets it up properly would be really nice to have.
Yeah, it's it's always tricky.
Yes, very tricky to try to make something that's going to work for almost everybody and not work very badly for anybody. Because I guess one other thing I was wondering about is, can we start branding our loaders with some kind of version number so that we can actually tell what is currently installed versus what's
we've been
existing?
We've been branding our bootloaders with a version number since 1993.
Yeah, I think they've all been version 1.0.
No, there was some
no, it's
for a while.
Okay.
We're to like 1.3 or 1.4.
Okay.
But it's yeah. If
those are usually,
we would need to solve the why aren't we updating this ever problem.
Yeah.
We used to have a date and time stamped in it, but the reproducible builds put the kibosh on that. So that's that is interesting. Yeah, Manu may be right that it's 1.1 everywhere. I know that Spark used to be 1.3. There was a 1.2 somewhere.
Yeah, I think the versions were usually bumped related to changing the actual.
Yeah, but that's the legacy.
Or whatever.
Yeah, that's the legacy bootloader, not the EFI bootloader, which is 1.1 everywhere. So,
but like for the case of install boot, how do we even just reliably detect which partition contains the boot code you booted from?
Okay. Okay, there's a couple of ways that you can do that. One is you can look at boot current, and that will tell you the boot variable set to look at, and that'll tell you exactly what was booted. The other way is it's what's mounted on boot EFI. We require people. We require one way to do that is require people to mount the partition that they want to update as boot EFI.
Right.
The bootloader, it's been slowly making its way into install boot. The other way you can deal with that is, is to sanity check and make sure that what's mounted is what was booted, and have a force if not.
Like,
and the other way is an environment variable.
I was just thinking,
you don't want to go looking for things to mount in general.
But I was wondering if the EFI bootloader could set a KENV with the GPT GUID of the ESP that actually did the booting. So when you have multiple disks, you can tell which ESP it was.
You mean like the two that it already sets? There's a EFI, there's a boot one set of variables that are set by boot1.efi, and there's a loader set of variables that are set by loader.efi that tell you exactly where you were booted from.
Oh, good. So that we have some information.
All the tools here. We just need to use them.
Yeah.
I mean, I hate to sound like, oh yeah, I've done all of this, but I've done all this and integrated none of it. So I mean, these are great questions.
Yeah.
The other thing that one can do early in boot, and I have code to do this in my tree that it doesn't work reliably, so I've not committed it, is I've got a dev EFI geom that looks at the booted root system and creates a dev EFI root, and it looks at the ESP that was used to get there and creates a dev EFI ESP. I wrote that before I wrote the code that added the extra environment variables, and it needs some updating. I haven't messed with it in a while, but when I first did it, it wasn't very reliable, and I didn't want to answer questions from people about why doesn't this work. I've primarily done it so that in the embedded space, we can produce images that just mount dev EFI root, and it doesn't matter where you boot
What
it
device
from.
it comes from, you don't have to try
Yeah,
to.
and you don't have to, you don't even, and you don't have to rely on other labels as well. But other labels worked well enough that there was not a lot of pressure to get that done.
But yeah,
So,
like I think for the case I'm looking at, it's mostly when there are multiple disks, especially if
Right.
you're mirroring them or doing RAID Z, and you might
Right.
have the ESP on all of them. And
Right.
we want to update all of them, although maybe not at the same time. I don't know. Probably at the same time, but having that geom device point to the one that we actually booted from might be quite helpful there.
Right, and that's the other set of worry. I have redundancy, but I don't want to use like gmirror to get the redundancy on my MS-DOS or on my FAT partitions.
Right.
Because I want one of them mounted all the time because it's convenient, but I want the other stuff not mounted. So how do we deal with that? And the install script, one of the things I was thinking that would make sense is if you just give it no args, it does the rock stupidest default thing it can do. And if it can't, it says, forget it.
Right. Is boot EFI mounted? If it is, does it have a FreeBSD directory? Update the file.
Exactly. But it can take a number of args that will tell it what to do. And you can give it a number of partitions to update and whether or not to mount them and unmount them and things like that as well. Now, this discussion's a little bit EFI centric because I want the same stall boot. I wanted to deal with, I've got this really weird ARM board, but it has a U-boot port and package. And I would like to update it, and I would like it to know that, oh, it's all winner, so that goes on to offset blah 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 of this device, based on metadata that's in the that's installed. Manu and I have done a little bit of work in this area, but we've not finished it. I think Manu even has a script to do the U-boot part of this as well, and part of it too is. He just said on IRC he does have a script, and part of it too is like you said, for legacy or dual, I want both updated, or I just want, I know it looks like I booted from EFI, but I want you to update my legacy. Should be a valid thing for it to do. Maybe with,
especially in the recovery case where you're booting from a USB stick, our installers try to boot EFI by default now, but that doesn't mean the system you're trying to repair booted with EFI.
Exactly. So so that's that is some of the concern. Also, our boot and GPT boot thing, you have this on your list here. What do we do when there's an error? I have 128K boot partition, and our current boot
I think it's 156.
is yeah, I was going to say it's 200K. But
I mean, in fairness, when I first wrote GPT boot, I think UFS boot was sitting at 8.5K.
Right, and up until I started messing with it,
still quite small. It was
PMBR couldn't handle anything over 64K.
Well, because that was enough for anybody.
Yeah. But then we added encryption and more hashing algorithms and a bunch of other things. And thanks to Colin, we could do more.
ZFS, I hear. I think that added a little bit to it.
Well, yeah, I think ZFS was already running close to the 64K, and then we went to town on it.
Yeah.
I think we have both now, so we can have one image, and
yes,
that also expands things a little bit.
And I think since 10.1 or so, the installer has always made the boot partition 512K, but there are lots of people who did their own thing at some point along the way. and run into the situation where, you know, their FreeBSD-boot partition is some smaller size than what it takes to fit the current one. And so, yeah, the script will need to handle the error there. But again, it'd be really nice if it could spit out a URL to the handbook telling you how to, you know, shave some space off your swap partition or whatever and make it bigger.
Yeah, that was one
And solve
of
the
the
problem.
options I envisioned for install boot too, which was, you know, do that shaving so that we wouldn't have to have people walk through it manually.
Yeah,
Obviously,
it's one of the
not
really
by
nice.
default.
Yeah, but one of the really nice things about GPT is that the order of the partitions doesn't end up mattering so much, and you can, you know, the boot partition doesn't have to be the very first one on the list. It can be at any offset, you know, because the other thing is the ZFS installer defaults to rounding the ZFS partition to whole megabytes. So there's sometimes enough slack left after the last partition as well to fit an updated bootloader. You know, and so, you know, you can get really complicated with the script of like, well, we don't need to shave off the swap if there's more than, you know, 512K of free space, some other offset in the partition table. But, you know, it gets really complicated and you start looking at all the possible options there.
Yeah, Patrick had mentioned a couple minutes ago the problem that I was trying to solve with boot EFI ESP, which was, you know, device names change and it's not the thing you think it is, and was saying that GPT ID would be good, and I agree with that. Having things be a little bit more robust than they are now, or at least you know, having that information available and widely publicized. One of the problems with the environment variables I did, you know, is I didn't put them in a man page. And so nobody knows about them. I mean, Alan, you've worked a lot with the boot code and you've overseen several people working on the boot code. And you and I have done contracts working on the boot code. And yet you didn't know about them.
Yeah, I haven't run.
I'm not digging at you, you know, by saying that. I hope you understand that.
Yeah, I didn't randomly run KM. It sees an extra couple of GUIDs in there and be like, I wonder what those are for.
Exactly.
I wanted to touch on before we get a little further. Someone already pointed out there's an open bug against 13.0 actually, because the installer tries to mount EFI, but it uses like dev 80A0 or whatever. If you change a disk and because it's not a fail OK mount, you suddenly fail to boot. Like if you insert a disk and it doesn't have the ESP where it expects, because we don't use some kind of soft label or something like dev EFI root that you were mentioning.
Oh, I thought the installer was using the GPT label, the -L flag when you partition, but maybe it's
But we also probably, if the mount is non-optional, if it's not like a fail OK mount, that. But it says no that it wasn't. It was using like dev 80A P0 or P1 or something like that.
Yeah, that should definitely at least have the fail OK, I think.
So that was bug number for reference 256179.
Can you send that to me on IRC so I can find it later?
Yeah, I will. It's actually on Discord, but I'll forward it over to IRC because we don't have enough platforms to work all together.
I'm on most of them, but I can't read them all. I can't read scroll back on all of them. But kind of getting to Warner's point about, you know, durability or you know, having it work consistently. You know, something I've been talking about at Dev Summit since 2018, I think at least, is having some kind of fallback process for the boot code, because, you know, when you update it and it turns out not to work, it's quite a faff to fix usually, and often requires find some other media to boot from. And, you know, if you're a poor user with one FreeBSD machine, that might be difficult. It's like, oh, find some other machine that works and make a FreeBSD USB stick to repair your broken FreeBSD machine.
Yeah, this is an area that we need to look at, but part of it, EFI has some things like this right now. The loader doesn't search as hard as it used to because you can set up a number of EFI variables. Now we don't when we install it by default, and maybe we should, so that you can say, oh, this one fails, quit out of this one, and it'll go to the prior one.
Next one.
It'll go to the next one if you set that up. GPT boot, it's harder. We have ping-ponging boot inside of GPT boot. And even in GPT, I even did a GPT boot.efi that does the same ping-ponging. That's based on some dodgy flags that we stole from some header bits that have since been, Intel's tried to reclaim them.
Oh.
They reclaim the field and tell people not to use it in the reclaim, since they're not actually in active conflict right now. But yeah, these are issues, particularly particularly when we've got people wanting to deploy servers. It's not just, hey, there's this one server out there. When you have teens of thousands of servers, you want something that will fall back and fail safe to something sane. And GPT boot does a good job. If you boot the kernel and something weird happens, if you have a watchdog, it'll reset and GPT boot will boot the next thing. Before you get to the point in the boot where you update it. And this is another area. I absolutely agree that I would love to oversee people working on this, but I don't have time to go through this, because it's actually quite tricky to get bulletproof, but it's actually relatively easy to get
at least
most
of the way there. It's less fragile than it is now.
Yeah, if we fail in 10% of the cases, we could go to failing in 1% of the cases with not a lot of work. But that last extra little bit is difficult.
Yeah, because with the loader for the EFI version, the fallback, we have to make sure that the loader exits when it runs into an error and gives us the opportunity to fall back to something else instead of just printing an error message and then sitting there forever.
Yeah. There's some versions of the bootloader that do that. And I've tried to eliminate all the ones that touch EFI, because panic in EFI used to be implemented as printf wall 1.
Yeah, I think in the legacy code, it is printf followed by a 4 semicolon.
Yeah. Maybe that was it. I forget, but basically, and there was one that did that in assembler. Jump dollar.
Yeah.
Or JA dollar or something. One of the MIPS ones.
I think on one of them I found that actually makes my laptop get quite warm if you sit it at the broken boot prompt.
Yeah. So what you had another number of other things. So we've talked about installing, and we've got bits and pieces. We need someone to thread them together. Maybe it's we have enough bits and pieces to make this a GSOC next summer, or an intern student, or something like that. I don't know the right way to get that worked on. That's one of the problems, bigger project problems. We don't have a good way of keeping projects like this on a list somewhere that's up to date and doesn't go stale quickly.
And ensuring that we have a way to do the kind of state transfer that would be required for someone who's not sitting here watching this talk right now, to be able to get up to speed and know, there's this thing GPT boot and it uses some flags on the partition table to ping pong between these two partitions, and we need to somehow extend that so it can decide to ping pong itself with something else or whatever.
Yeah, extending it to GPT boot itself is hard.
Yeah.
Who watches?
Well, you basically somehow have two different FreeBSD boot partitions without confusing the PMBR code.
Yeah, that could be interesting.
Yeah,
that's an interesting notion, though.
Because I don't. Yeah, it might not actually be possible. You'd have to make the boot 0 that's concatenated that's got boot 1 concatenated on it in the FreeBSD boot partition do the failover or something, I think, because you only have the 400 and something bytes of assembly in the PMBR to make the decision. I don't think there's room to add parsing the flags out of the partition table to it.
Okay, so we have avoiding disaster. There were a couple of other things about performance we're getting short
yes.
on.
Oh yes, so let's move ahead. Then we just, we have the same problem with ZFS. I'd like to restore the upgrade instructions, but it'd help if we had a tool and then some instructions that we could point people to.
Right, right. And I can write up, or at least get started on a thing, and so we have a place to point to.
Yeah.
And
you know, the next version.
Because right now it's like, yeah, hope for the best. No.
Yeah.
And we could at least have the ZFS case.
Yeah. Well, in particular, how to, I guess, teach people to be able to use gpart show and figure out which one is the one they're booting from, and update it. Find the right device name for GPT boot part or boot code on the legacy case, or how to figure out how to mount their EFI partition if it isn't already taken care of by FSTab for them, and deal with that. So yes, on to performance. So Colin has done a bunch of work previously on a system called TSLog, which basically logs timestamps in the very early part of boot, where tools like dtrace and so on just weren't available yet. And he's recently extended that to go as early as the loader. And on my next slide, I have a flame graph he made out of that. And he's identified the problem, but not the root cause at this point. And then secondly, Mitchell Horn has been working on upstreaming some code from NetApp called boottrace, which basically takes over just around the time where TSLog stops, including profiling all of the RC scripts. And so with those two things in, it becomes a lot easier to look at what's slowing things down during boot. So from Colin's flame chart, you can see that a lot of time in the loader is spent loading the font. And there might be something we can do about that. I think the font file is only 170K or something. It doesn't seem like it should take all that long. But I think in total, he found there were over 20,000 IOPS happening in the 5 or so seconds in the loader. And if there's any way to make that smarter, that would likely save a lot of time on the boot process.
Yeah, it's probably a legacy of back in the day, in the 90s, where there were enough BIOSes that couldn't do more than one IO at a time, or one sector at a time. And so all the code was kind of written assuming that, and we don't try to do any read ahead or clustering or anything like that.
There's a little bit of read ahead, but I think it tops out at 16 kilobytes of read ahead.
Well, and this is not EFI, right?
This is not the EFI case because I think Colin wasn't sure if some of the older instance types on Amazon can boot EFI or not. I think they can, but.
So the other constraint you have is you don't know, with the BIOS interface, there may be a flag that we don't check, but I feel like there may not be. You don't know if it actually has to be in the low 1 meg because not everything can bounce buffer. And so that's also the reason. So we actually, or I think we do check for that. Like, so floppies, you can't bounce buffer. So it actually, and it has to be a small, like we're constrained with doing really small IOs to buffers on the stack. And so I think it's also true that we just do lots of small IOPS for the non-EFI case. And that may not be fixable versus, I mean, I would say that we should, if we want to optimize, we should really probably focus on EFI going forward and not spend a bunch of time on libI386, because I think some of the things might not really be fixable without breaking other systems.
Right, and so some of that might just be getting more of the AWS instances to booting with EFI instead.
Yes, I think that's a better use of time, if that's possible.
Yeah, but I don't know how much further Colin's got. He's been a little busy lately. But his goal is to make AWS instances boot up more quickly. And then for the boot trace stuff I mentioned, Mitchell has the first 2 reviews for that out, which is mostly the kernel side of it. There's a user space side, and then the reviews for that will come up soon as well. But there are the URLs for that.
So Mark Linneman had suggested that we get together and have a monthly call. But what might make sense, Alan, is for you and I, and we can send it as an open invite to the whole community.
Mm-hmm.
But set a monthly session where we just go through and bang out a requirements doc or bang out this tribal knowledge that you have and that I have that nobody else has. And I'm sure there are others. I would invite Emmanuel Vado to this too, because
right, and Kyle Evans and
yeah.
Tomas Sum for sure.
Yep. Oh yeah. All of those have a different. All the people there have a different piece of the tribal knowledge,
Mm-hmm.
and so that would be useful. I think even if we just did it 2, 3, 4 times, a couple hours a month isn't going to kill anybody.
Yep.
We could improve the state of the art quite a bit. So, and then also maybe set the framework for somebody having an approachable document to get the context to be able to do the little bit of work that's required. Because right now,
exactly,
paging all of this in is quite costly.
Right, and it involves begging for time from each of the 5 people we just listed, and
you don't know which of each of the 5 you need.
Exactly. So yeah, I think that makes a lot of sense.
So it's been a perennial problem.
Yeah.
Yeah. One of the questions was Bakal was suggesting that we write a man page and let people code to that. So I think between the two, I think it'd be good.
Yeah, like I don't know if something more like not the architecture handbook or whatever, but for HBSDCon a couple years ago, I wrote a big chunk of my paper was just describing how the legacy boot process works in all the different stages, starting with a more handbook-like document that walks through those steps for the 2 or I guess 3, right? We have legacy, EFI, and U-boot are the main boot types. And maybe Justin will want to jump in and add whatever PowerPC does to the list. But
there's a
KX try to write more of it somewhere. Yeah. But I guess the other question was, what else would people find useful, or are people working on for the boot code? Like I know Kyle and yourself have recently extended the Lewis stuff and created the vendor menu option, which I'm sure anybody who tried to add a menu option to the 4th in the past greatly appreciates the fact that they can just make a little file with a little bit of boilerplate and just add a menu option and not have to do the craziness that was required in the past.
Yep.
But is there anything else people would like to see there? It'd be helpful to have an idea of what people's pain points and wish list are.
There's 2 things I think that are in IRC right now. Manu is working on a tri-kernel that will, he's describing what that will do. I think it will try it a couple of times. If it fails, fail back is where I'm going.
Oh yes, I know I looked at something like that for ZFS in the past, keeping a counter of boot attempts, and if 3 times you didn't, when the system comes up all the way, it resets the counter to 0. If the boot code detects that the counter is 3 or more, it will boot a different boot environment, like a rescue system or a phone home system or something.
And then Chris says that there are a list of known working configurations for a console through IPMI. Basically, if your vendor supports doing console redirect, then generally the vendor puts that in the right con out variable, and it just works. If it doesn't, you're kind of screwed, and we don't have good fallbacks on EFI. And the way you specify things in EFI is a little bit funky. We would need ACPI parsing to potentially do it completely, but we could get a lot even without that by having us having the EFI bootloader console still do both, and then having an EFI video and an EFI con, or whatever we want to call the names, that are specifically, this is video, this is console, or as well. And that would also let people that do not want the graphics ever, to have bootloaders that do that. I mean, that's a really cool feature by Tumas. That's great for my laptop, but for servers that I can't get the rendered stuff, it is less helpful. So so that's Crest is also hitting on another issue, which is we don't communicate from the bootloader to the kernel what the console should be. And that's one of the things you don't need ACPI in the bootloader to fix. And I have an idea on how to do that. If somebody wants to do that work, let me know. I'll be happy to schedule a Zoom call and give you a brain dump. It basically involves checking or passing the UID of the serial device to the kernel, and then having a little bit of code in the kernel that looks for that and uses that as opposed to the old style IO port address to select the console. So
schedule wise, we're kind of bumping up close to where we need to cut it off. And we're going to take about 5 minutes and then come back for Warner's session on workflows, which I think is also going to be a little tight to fit into the time allocated. So I definitely don't want to start late. So I would encourage folks to continue discussing, since clearly we're not done, over in the hallway track. We could also, after today is over, the hallway track will be open if folks want to continue talking about this topic, or quite possibly Warner's topic. After the main track is officially over, the hallway track will be open for quite a while. We can continue talking about things there. But let's go ahead and go into about a 5-minute break, and then we'll come back and start with the Warner session on workflows. Thank you, Alan and Warner.
Thank you.
you bet.
Hi, everyone. Welcome back from our break. So our next session for today, I think, is going to be a lively discussion. So let's get right to it. So it's Warner Wash, and he's going to be talking about workflows for the FreeBSD project and evaluating some of what we can do in a Git world, I believe. So let's see, Warner, are you ready?
I was automatically muted and okay, so I have video. I don't have video from my camera, but I'll just talk into that if people can just listen to my talking slides. So let me bring my slides up.
Yep, that'll work.
Yeah, I don't know what happened. I had video earlier, now it's off, so I don't have time to troubleshoot it right now. So can you see my slides okay?
Or
Yes.
you can turn it back on. You just turned it off for the break. If you hit your button, it should come right back on.
Okay. Whoa. Okay. I will give that a try, except I'm presenting, so I don't need video to present. Anyway, today I'm going to talk about the FreeBSD workflow that we have. I've been looking into this for a number of months. I hosted a couple of roundtable discussions. It was motivated because we've recently moved to Git in the past 6 months, and Git lets us Git opens a lot of doors for us for improving our workflow. Right now, the transition to Git was purposely a great leap sideways, where we moved to Git and kept about the same workflow, mostly to get people in the project used to the new tools, get our users used to the new locations, get all the documentation updated, and get all the internal project processes that we're pulling from Subversion, pulling from Git. There was a lot more there than I had anticipated when we started this. And so I held a couple of best practices roundtable, hoping to say, well, these are the best practices. These are the things that work. The project recently moved to ASCII Doctor, and I can write ASCII docs. I had trouble writing DocBook docs. So I thought, hey, this would be great. And in doing that, I learned a lot. In addition to talking to the people at the roundtable, several individuals reached out to me, and I had productive conversations with them. I also talked to our bug busters to see how well Bugzilla is working out. And Mark Linneman had some extensive information that he shared with me, and I'll talk a little bit about that later. Also, while this was going on, Fabricator announced it's going EOL, and the project will need to do something about that. But, I can summarize pretty much every single conversation I had as some version of, there's too much friction. And the friction is something that presents a needless barrier to entry or requires additional time for people to do their work, or for even for people to contribute to FreeBSD who aren't developers, or in some cases for users using FreeBSD. And this is an area that we should be the focus of any of our efforts to improve our workflow. I have a number of types of frictions that are listed here, ranging from the simple actions take extra time. Right now, if I wanted to commit somebody's submission in Fabricator that's been reviewed, I have to manually transfer that to my computer and manually transfer a bunch of stuff. And even though Mark Johnson's scripts have made that easier, there's still some area for improvement. But it's more than just tool integration. Some of our policies and our current setup don't work well. I went and looked at the number of GitHub pull requests we had open. We had 42. Maybe 10 of these were bogusly open. And by that, I mean the fix was there, it had been accepted, and someone had committed it. And the pull request simply wasn't closed. Now, sometimes they committed exactly what the pull request was, and sometimes somebody else fixed exactly the same problem and the pull request was obsolete. So those were easy to close. And then in a number of cases, there was a good discussion. Hey, I want to do this. Oh, fix this. Okay, sure. And it became, it was something that wasn't good, perfect initially, but became good. And but then it was never committed for whatever reason. And so this is kind of a common theme. We have the same problem in Bugzilla. And so we need to look at ways that we can have some oversight for when the normal policy, when the normal functioning of the project fails. Another area of friction is sometimes as developers, we try to do too much. Somebody submits a patch that's almost good and you spend a lot of time dinking around with it and trying to figure out, stuff that we could easily ask the submitter to do and more efficiently use the developer or the reviewer's time than doing any, than we're doing now. There are also a number of technologies that can improve quality, and we could leverage that. Our existing CI is okay, but it's after the fact. There's no screening of new submissions with it, for example. There's no validation of reviewed submissions for that. So we can use that to both improve the quality and also improve the efficiency of the project. And finally, there's a few of the issues I looked at, both in Bugzilla and in the GitHub pull requests. It was unclear who was going to do things. So it wasn't clear who was going to do the commit, so nobody did. So having a clear definition of roles and having that become ingrained, and also having some, what happens if that doesn't happen, having some fallback that's relatively easy and lightweight, I think are what we need to do. And so I've talked about tool friction right now a little bit, but right now the tools that we use they're adequate maybe, but they're not good or great. There's a number of manual steps required. They take extra time. They don't fully leverage everything they could. They need to be better integrated, and the better integration would help, but not solve the problem. We have, like I said, policy or friction, and these are policies that we're doing. We're executing what we think we want to do, and it turns out what we want is wrong because it's creating extra work for our volunteers. We document things poorly, so the submissions that we get are not very bad, and we have, an inability to get to closure on a lot of issues. This has been a perennial project problem going back to the use of NATs even. So it's independent of tools. And then finally, I heard from a number of people that we have what I'm calling clutter friction. And that's, other ways of saying this is it's very easy to get overwhelmed. If I go out to Bugzilla, there's no way for me to go look at like all the storage problems or all the MMC problems or anything like that. It's a very big set of problems that come up by default, and it takes a lot of work to winnow that down into a useful list that you can look at and glance at and know whether or not to do things. And so you spend all your time finding stuff to work on, and then you find you don't have any time to actually work on things. So it's difficult to focus on what needs to be done next, because also there's a mix of quality in the bugs from this is a perfect bug report with a perfect fix to yeah, I booted and it didn't work, and not a lot else. Now Mark has done a good job of actually removing some of those, but the quality problem still remains. So to make progress on this, a lot of people have been talking for a long time, hey, we got to fix it. Well, we need to do more than say, hey, we got to fix it. We need to articulate a set of problems that we want to solve, and we want to have a number of measurable goals that we can use to solve them. How do we know we're making progress? How do we know we're working on the right thing? You know, and we need to understand the timelines. So I'm thinking that we need to figure out where we want to go and then figure out how we're going to get there. And that probably needs to be a working group, and it probably needs to be maybe even several different subgroups to make this happen. So looking at the tools we have today, Fabricator. Fabricator is on its way out. I think there's not going to be anybody that says, I want to use Fabricator forever. I'm sure somebody will ding me on IRC and say, oh no, I want to use it forever. But Fabricator's reached, the original developers have said it's reached end of life. And I'm going to actually punch George after the session because he told me he did what I told him to do. But it's also a poor match for our workflow. It's hard to get emails out of, commit messages are difficult to curate, and we need extra tools to make it only a pain to use. So while there's no rush to move away, because we've got instances that we can use and modify if we need to, we need a plan to move. And this was true before the end of life was announced, and it's just as true afterwards. It didn't make it less necessary. But Zilla, we're doing probably an almost adequate job of keeping up. Mark is doing a good job of filtering and directing the bugs, but we can do better. And this is one area where I think we've done as well as we have through heroics, but we'll need some automation to do better. Mark has reported that he thinks we're either barely keeping up or not keeping up or falling behind, depending on which week I've talked to him. None of those is a, yeah, this is no problem. It's not entirely clear if the problem would be solved by a different bug system, or if we need other tooling to solve it, or there's cultural things we need, or we need to reorganize how we use it. So those are things that the working group I'm seeing would need to discuss. Jenkins, this quote was in yesterday's core report. Nobody hates the Jenkins more than I do, from Lee Win. And he clarified that it's mostly the email that he gets either from people who break the tree, and he gets extra email because of that, or because of the email he generates and sends to them because they broke the tree. So it's very frustrating for him. Currently all of our testing is after commit. It creates a lot of things, but it also leaves the tree, it catches a lot of problems, but it also leaves the tree broken for a while, and which can be frustrating. If again, it's another source of friction, where you go to do something and you build and it doesn't build. So we need to work on that. Now the test scripts that Lewin has had are dependent on Jenkins, and work will be needed either to make them be dependent on something else or to make something else use the Jenkins results. And it's unclear what the best path forward with this. The good news is that Lewin wrote a lot of his scripting to make it easy to move away from Jenkins, and the actual scripts themselves have no dependency on, or the actual tests themselves have no dependency on Jenkins, but instead depend only on ATF and QA. We're using CRCI, which is great. Ed Mast wrote a script that does a simple smoke test whenever you push a branch to GitHub or GitLab. I've used this and it works okay, but since it's using the free services, there's limited CPU time available. And we could do more in this area because it's, and the testing isn't directly tied to GitHub or GitLab, but that's where CirrusCI gets the branches and changes to run its tests against. And we also have a number of people policies, like our people policy process social problems that we need to address. If we think we can just change our tools and everything will be great, I think that's an unrealistic expectation. One of the big things I noticed was that the process lacks oversight. There's nobody that goes around and goes, oh, this looks like it could be committed. Let's ping somebody to make it committable. I found 4 or 5, I believe, changes in the GitHub pull requests that I sent email to Hans. Hey, Hans, can I fix this? And Hans says, yeah, that looks good. And I was able to push it in. You may have noticed I made a number of commits. So what do we do when things drop on the floor? Ports maintainers have a 2-week timeout, and that works okay in the ports tree, where all that's being updated is basically a leaf node port. But even the ports tree has special rules. If there was a maintainer timeout for a critical port, the result wouldn't be an instant massive upgrade of that port. There are other processes in place. So there's degrees of degradation that source could use and doc could use to help with this. The other thing that I noticed is other projects aren't shy about telling people, hey, this patch needs to be improved. Here's how. Send it back to me when you've improved it, and then moving on. We've historically been really bad at telling people no, or break this up into smaller changes, or make this reviewable, or even providing guidance on what a reviewable patch is. We need to look at ways and changes to the way we do business so that we can make better use of more people in the community, which will also probably have the knock-on effect of getting more submissions from users landed into the tree and getting them more engaged, and maybe even growing and maturing developers in the community. So I talked a little bit about the people problems. I'm a little bit short on time, so the next few slides I'm going to kind of breeze through. The last point on this, I think, is the 2 points that I wanted people to take away are, what do we do when the process fails? There's no backstop. And how can we as a project get better about saying no and providing the right kind of review at the right time? Also, what happens when our process breaks down? Maintainers get busy, people go on vacation, people lose interest in the project. All these things need to be accounted for in our process. And right now, what happens? Basically nothing. And so this leads to very poor user experience or submitter experience or contributor experience that people that want to help out are discouraged because they try to help and they're basically rebuffed. It doesn't matter internally why they're rebuffed. Did we do the first 5 of the 6 steps we needed to right and then drop the ball? Well, to the external committer, it doesn't matter. In fact, that makes it even worse. Because, oh, hey, they did something and then nothing happened. That's even worse than just being completely ignored. So we need to find a combination of automation and people, I think, to work on this problem. The division of labor is more of, how do we, how are we able to use our developer resources better? One way of doing that is by having things to review land in their lap pre-screened, either by a person that takes a quick look and goes, yeah, that looks like it might be good. Or, that isn't trying to sell me erectile dysfunction pills. It's a legit change. Also, it's been through some automation that says, well, at least builds, and the first level of style has been checked, and it gets bounced back to the contributor right away, and they have a chance to improve and update it for us to take a look at it again. One of the problems in the past, there's a lot of people will take a look at a patch and go, I don't even know where to begin to say that this is wrong. And rather than provide even that feedback, it's like, I'll go to the next one that's easier. So the project has had an ability to provide feedback that's negative, and to close issues that are rejected as actually rejected, whether that be feature requests for systemd, although I think all of those are closed, or patches that check to see if something's not null, that never should be null. Rather than fix the underlying problem, it puts a band-aid on it and doesn't actually solve anything. And as you can imagine from the rather animated way I'm talking and the speed at which I'm talking, I could go on for a long time, but that's it for the summary. We need to have some strategic goals. And as I mentioned earlier, we need to reduce friction. And there were 4 areas of friction that I came up with to make the workflows go more efficiently. Now, there may be others, and this is just a preliminary list, but I think it's a good place to work from. We need to reduce the friction of screening submissions. When we get a submission, how can we validate it that it should go on to the next step, or reject it automatically where nobody needs to be involved, or they need to be involved maybe just at the last step to click OK. We need to reduce the friction in reviewing, revising, and or rejecting submissions. Right now it's hit or miss. And once we have a submission we think is good, it passes the basic test, how do we validate it so that we want to land it in the tree? And how does this feed back to the other parts of the step? And finally, how do we make sure that it gets incorporated into the tree? And another key thing is we need to reduce latency at each step, even if that means rejecting more things. And the reason we need to do this is if we can have a low latency to rejection or to feedback to make it better, we can get better submissions when people are still interested in the problem. If I see a patch from 4 years ago, I know that the likelihood of my sending it back to the submitter saying, hey, yeah, I know this is okay, but you only handled half of the cases. What about this other half of the case? Can you modify it? I'm going to get probably crickets or an angry email about how I ignored you for so long and now I'm demanding things, or something like that. And finally, we need to look at ways of adding resilience in the face of process failures. We have some okay processes, and if we come up with better processes, they will fail. And we need to figure out, what do we do when something doesn't get a review? What do we do when something looks like it should go in but hasn't for some reason? What's the, how do we unblock the system for things that catch in any of the phases of the system? I also looked at possible solutions that would just be a drop-in. And nothing's just a drop-in, but we have a GitLab cloud-hosted solution where we basically take everything and put it on GitHub, and we do all our interaction there. That has its pros and cons that are too numerous to mention here. We could do the same thing with GitLab. Different set of pros and cons. The advantage with GitLab over GitHub is that Bugzilla is integrated with GitLab, but it's not integrated with GitHub. There are a couple of dead projects that look like it tries to, but there doesn't seem to be anything. We could also run a self-hosted GitLab. That would mean we would use the current credentials, and we would have the current branding that we do that we would lose with the cloud-hosted solutions potentially. Some people have mentioned TeamCity. Nobody's stepped up to volunteer to do any work on that. And when I heard Garrett mentioned it all, it usually was part of the phrase, "Dear God, anything but Garrett." I think there was one person who mentioned it, remembered it favorably, but all the others were just no. And when you look at other projects use email to manage a lot of this. And the only reason that it works is they have a lot of automation built around the email, not because of email itself. Although some of the projects seem to think that it's because they use email and it's so simple that it works. I disagree with that view. And we're certainly not set up as a project to do that. And it would take a lot of rejiggering. It would be a very high friction way of solving this problem. So we have basically 3 potential solutions, maybe 4, that could help us, that we could measure against the goals of reducing friction. None of them are clearly the best way to go. All of them have issues, and we need to figure out which issues we can live with and which issues, what trade-offs we want to make. And that's why we need a working group, to basically work through all of these issues and figure out, well, GitHub looks good. Is it really? GitLab looks good. Is it really? What are the pain points of each of those? And we need to do this in a way that is not a never-ending navel-gazing contemplation exercise, but that makes progress and moves us forward to having a more friction-free environment. And so, a lot of the trade-offs and nuances are hard to do in a large setting and need a more focused setting. So also all the requirements that we would use to judge what is the best, they're not really articulated now. Most people have a good notion intuitively about maybe what might be a good set, but nobody's sat down and written them all down. And all of these are tasks for the working group or subcommittees of the working group or something, so that we can move forward. So did I just drop out of presentation mode? I think I did, sorry. So one of the things that we also need to do is we need to set a measurable goals. If we have a working group, we're going to need some oversight of that working group to make sure that they're working towards making progress towards a solution, that they have a set of well-articulated goals. In addition, that we put into place metrics about what makes it successful. Let's say we chose a particular solution. How do we know that it's working for us? Are we getting, did we decide, hey, we want more contributors, or we want more commits, or we want a higher velocity, or we want the build broken less? Well, we need to measure those things. And, we need to measure it before and after the cutover to see if it's working. And it's going to be something we need to continually look at. Oh, we tried solution X, it didn't work. Maybe we need to try solution Y or tweak X or something. This isn't going to be a fire and forget sort of problem, but something that we need to deal with on an ongoing basis. And so I've talked about most of the proposal. We need a working group to work through these issues. We need to have a good combination of short-term and long-term goals. Short-term to get rid of the worst of the problems we have, and longer-term to solve some of the more systemic things. And I'm proposing that this be an open process to anybody who is willing to constructively participate. And if you are willing to show up and do the work and respectfully communicate, and there's a seat for you at the table. And I'd like to open it to all members of the community, not just people with commit bits. I think having a diverse group of people here in terms of where they are in the FreeBSD ecosystem will make the entire ecosystem better, and we will wind up with something that works better for the community, and we might get a more healthy community out of the result. I'm also proposing that I'm the initial chair to get things going, but if somebody really has a fire in their belly and wants to plow through all the nuances of project management and technical duty issues and project politics, I'm open to having discussions about that. So I think I've taken most of my time. There was one answer in the Q&A.
You can read that if you'd like.
I'm reading it, it's long. But basically it's, what is the project policy on handling bugs filed against releases no longer supported? Can they be closed outright, leaving the submitter or someone else to reopen a new bug? I looked at one yesterday filed against 9.1 where the bug clearly indicated it hadn't been fixed in the newer release, and the submitter just wanted an MFC. I think that's a great question, but I think it's a little bit beyond the scope of what we can talk about here. But that's exactly the kind of thing that we need to be more clear about and document better. So were there questions in IRC? When I'm presenting, I can't tell. When I'm just talking to Alan, I can look at IRC over my shoulder.
So one that Christoph had in the Zoom call is he said one thing he really wants from bug tracking is the ability to kind of put into a state which says it needs more information and auto close in some predetermined amount of time if the information doesn't come back.
Yeah, I think that's great. I think that's a popular suggestion, Yeah.
And I think this is, I think part of what, like it's similar with David's question that you read, some notion for how to not have bugs linger in kind of this weird limbo state, like figuring out ways to have more bugs be a little more actionable and get to close one way or another. And not, because I think it's right now being open is a very ambiguous, it can mean a lot of different things. And so it's also frustrating for users because they don't know which of the different things being open means. If someone looked at it and said, I'm too polite, I don't want to say no, or nobody's looked at it, or it just means too many different things.
Or I've got a patch in my tree, and if somebody asked me about it, I would actually spend the 30 seconds to rebuild it on the latest tree to see if the other bug that was preventing me from working on this had been fixed yet. Yeah. Nobody knows if it's an inch away or a mile away from being committed. So so steps forward from here is we have a number of open questions on where do we go from here, and we need to kind of figure out a long-term game plan and a short-term some short-term tactical things we can do. The first of the short-term tactical things is this discussion probably needs to move to the hallway track. I'm either 2 minutes short or 3 minutes over on my time slot.
You're a little over.
I think 3 minutes over. And that was, I gave one version of this talk where it took me an hour. So I've done a good job of condensing, but I think it shows that I planned poorly with the time slot I requested. And we'll need to talk in the hallway track after this talk, and both before the next talk and this afternoon, and figure out how we can get the working group going. The Git working group had its last meeting on Wednesday or Tuesday, by the way. And so there are some people who are working on it that have suggested we use that time slot and start this working group there. And so that's probably going to be where I start this, but I'm also interested in that. So, and I even spelled Garrett wrong, it looks like. Well, that shows you how seriously I took it. I couldn't even be bothered to look up how to spell it.
I mean, in their defense, there are people who like Garrett. I think part of what when I sat in the roundtable is that people tend to be very warm or cold. And actually, in our group, there was one person, Simon from Juniper, who was he was like the first person you had encountered who was just kind of medium. Like, it's okay, yeah. I can eat it. But he didn't like love or hate it, whereas a lot of people seem to have very strong opinions one way or the other on Garrett. Not a lot of middle ground. It's
one of the few things that's more polarizing than signing the GitHub terms and services.
Okay, well, I think probably time-wise, we need to jump into a break. And I think you're right. The hallway track is a great place for folks to follow up with more questions or other things about this topic. So we've got a few minutes. We'll do about a 5-minute break here before we go into our next working group. And I certainly think we probably can't fit a lot of talk about this into the next 5 minutes. So probably after the whip sessions today, I think we'll probably have some time in the hallway track where we can discuss this further.
Yeah, I have some other engagements, but after the this will be hit or miss.
Okay. I mean,
but
we have
after
time tomorrow as well that we can use in the hallway track after the closing session. So we'll find some time that we can, several of us that folks are interested can get together and we can talk about this.
Yeah. Yep, that sounds good. Either after either around the work after the work in progress sessions maybe today, or sometime tomorrow afternoon if we don't get enough time today. Does that sound good as a
plan? And we'll figure out how today goes, and then if we want to, I can announce it tomorrow if we need to continue tomorrow.
Right,
so
and
let's go with that.
And it doesn't all have to get done this week. We can do stuff later, and I can send out an open invite and just have people show up, and I'll manage that, and we'll go from there.
Okay, sounds good. Thank you, Warner.
Oh, you bet. Thanks, John.
Okay. So let's go ahead and have another 5-minute break. And when we come back, Mitchell Horn is going to lead a session on RISC-V. Okay, welcome back, everybody. Thank you for being with us so far today. We've had some pretty lively discussions. Up next, we have Mitchell Horn, who's going to be talking about FreeBSD on RISC-V. So Mitchell, you about ready to go? I see you.
Yep. Hear me okay?
Yes, I hear you.
Great. Just gonna share this. Okay. Hello, everyone. Thanks for coming to this session. My name is Mitchell Horn. I'm a FreeBSD source committer, and I've been working on the FreeBSD support for RISC-V for the past couple of years. So what we're going to talk about today, we're going to briefly cover what RISC-V is. We're going to talk about the software status from the perspective of FreeBSD. We're going to talk about the hardware status, kind of in relation to what hardware is available and what is FreeBSD's support for that hardware. We're going to talk a little bit about the kind of upcoming changes to the RISC-V spec and the standardization process around that. And at the end, I'll give my thoughts on and perspective on kind of where we are going as an operating system supporting this architecture. And then we'll end it off with some questions and discussion. So briefly, RISC-V is a CPU architecture, much like x86 or ARM. What's kind of unique about it is that it has an open source license, so you don't need to pay any fees or have any special licensing to implement a RISC-V compatible CPU. Anyone can do it, and the instruction set architecture itself is designed to be modular or extendable, so that if you are implementing a RISC-V core, you can include or exclude the portions of the ISA that are interesting to you. So, for example, why implement a hardware floating point unit if you know that you're just building an embedded chip that will never need it? That's kind of the idea there. RISC-V is a young architecture on the scale of CPU architectures. I believe the first publication was 2010, possibly 2012. It's kind of in that range of, this is only a decade old or so, and FreeBSD's support for it has existed since initial version in 2017. So it's quite young on both the software and hardware side, and we're going to kind of see a little more about that. And then finally, I would say that an ISA like RISC-V is more than just that. It's more than just what instructions does the CPU run. It's kind of, from the perspective of the OS, it's what do we support when running on this platform? And platform is a little broader in scope than just ISA. So we'll come back to that idea as well. The ISA is broken up into kind of the base and extensions. So you can have a 32-bit RISC-V core, you can have a 64-bit one. The specification has made provisions for an eventual 128-bit core. And on top of that, you add your extension. So if you need hardware floating point, you add the F or D or Q extensions as needed. For atomics, you would implement the A extension for atomic instructions, and in that sense, it's modular. So at the bottom, I have examples of, all of these are kind of valid RISC-V implementations in the eyes of the spec. For FreeBSD's RISC-V support in particular, we support the 64-bit GC RISC-V core. So This has kind of the subset of functionality that you'd expect to see in any CPU that can run Unix, that can run FreeBSD. So the hardware floating point, the atomic instructions, multiply and divide, those are all required by our RISC-V port. We expect the CPU to have 3 privilege modes. The M or machine mode, it typically runs the firmware. The supervisor mode, which is kind of the middle privilege level, is what runs the OS, so the FreeBSD kernel, and user mode, which runs user applications. And for FreeBSD, as with any other architecture we support, we expect that it has a memory management unit. In particular, we support the 39-bit virtual memory scheme defined by the RISC-V ISA. The official RISC-V target is RISC-V 64. There is a soft float variant that's supported in the tree where you don't need to support the hardware floating point. That doesn't get as much attention, and I think it's kind of an open question. Will we need to continue supporting that in the future? But it's a low cost right now. So FreeBSD just had a major release of 13.0. So for the RISC-V port, where are we as of FreeBSD 13? Well, one of the, I think, big achievements in 13 is that you can cross-compile any supported FreeBSD architecture with the version of Clang that comes in base, and RISC-V is no exception there. So there's no need to kind of get your own external compiler. You can just do a build world and specify the target, and it just works. The RISC-V port ascended to tier 2 support from tier 3, where tier 3 is kind of the experimental or in development architectures. As of FreeBSD 13, RISC-V meets all the requirements of tier 2. So it's unofficial support. We don't necessarily provide security updates or things like that, but you can expect that the support in tree works and is maintained, and it will not break too often. Good support for the QEMU software emulator platform and the Hi5 Unleashed, which was the first Unix-capable RISC-V system on a chip that was released a couple of years ago. We support booting with UEFI and U-boot. So this kind of looks identical to how you would boot on kind of an embedded ARM or ARM64 platform. You have your version of U-boot particular to the system on a chip, and it supports the UEFI specification, so it can load our FreeBSD bootloader. And then finally, as of FreeBSD 13, we started producing release images for RISC-V. So the installer, virtual machine images, and a kind of generic SD card image are all produced and available for download. So as of FreeBSD 13, I would say that kind of the major achievement is that RISC-V looks it looks the same as you would expect for other architectures in terms of support. We have CI, it can be built easily in the same way that you do others. We have release images. It's no longer a specialized in development platform, and the barrier of entry has lowered a little bit, at least on the software side. Now, beyond the base system, talking about ports and packages. So in the last year or so, we've done some experimentation on cross-compiling packages for RISC-V using the Poudriere and QEMU user mode emulation. This isn't a perfect process, but it works pretty well, and some 20,000 plus ports are buildable. That doesn't mean they're all tested necessarily, but they compile. And new as in the last 2 weeks, there are some official packages being produced for RISC-V for both the 13 quarterly branch and current. So this is great. This is really great because it means you can say download the FreeBSD RISC-V virtual machine image and say package install Vim, package install Git, and you have it. Whereas before you kind of had to do your own configuring. And then kind of in the future, what will be next is there's still lots more ports and packages that just require small tweaks or patches to fix them, make them work on RISC-V. And then I guess the larger items would be adding support for more language runtime, so Rust and Go and Java and anything like that, because that enables a whole other set of software. So that's mainly where we are on the software side. I want to talk about the hardware side. For a long time, RISC-V hardware has kind of been untouchable to just a standard user or people who aren't in the know or don't have a RISC-V FPGA softcore that they can run it on are kind of just out of luck. And even myself, I've been working on this for a couple of years, and I only ever used QEMU up until recently. So this year and next, I think, is kind of an exciting time for people who have maybe had an interest in RISC-V, but they said, oh, well, I don't have any access to hardware, so what's the point? So we're going to look at some of these boards that are coming available. The microsemi polar fire system on chip, this was made available last year. It's kind of based on the earlier Sci-Fi Unleashed. It has the same CPU Sci-Fi cores in there, but this particular board comes with an FPGA fabric. So it's kind of similar to the Xilinx Zinc boards, if you've heard of those, where you have real CPUs that you can run FreeBSD on, but if you're interested in kind of putting something on the FPGA that you can interact with, that you can do with this. So this is it's fairly low powered board, but it is still available for purchase. You can find that on Crowd Supply if you were interested in this one. Specifically in the FPGA aspect, I think makes it an interesting platform. We don't have upstream U-boot for this or boot support, but as far as I know, FreeBSD does run on this. And since it's based closely on the Hi-5 Unleashed, that's not very surprising. Hi-5 Unmatched is the successor from Sci-5. This was announced last year, and after some shipping delays because of supply chain and everything like that, they've started shipping in the last couple weeks. It's available again on Crowd Supply and Mouser still. This one comes in a mini ITX form factor and is kind of being marketed as a RISC-V PC, the first one ever. And this is a kind of an interesting choice on the part of Sci-5, who produces this board, because they're pretty much an IP company. They sell their CPU IP to other companies, but they're producing a set of these boards to kind of push forward the RISC-V hardware ecosystem. So this is, it's still available for purchase. This is going to be probably the best performing RISC-V hardware we see in the next year or maybe 2 years. But it's not necessarily the best value. One other notable thing about this board is that it has a PCIe slot. So in terms of FreeBSD support for this, I don't think anybody's done bring up yet, but people are starting to receive boards. And since it's similar to the previous Sci-Fi board, we'll have support for some of the drivers already. And I guess the main bit will be a driver for the PCI root complex. But you can expect to see FreeBSD support for this year, I would say. The Beagle 5 is another board that was announced in the last few months or so. This one is marketed a little different as the first affordable RISC-V computer. So coming at a lower price point, this is not trying to compete and be a RISC-V PC, but it is a compelling system on a chip. There's 4 cores, 8 gigabytes of RAM, and it comes with it's going to ship with a GPU and AI coprocessors. So things like computer vision accelerator, which is kind of interesting. This board is not shipping yet. I believe later this year is the expected kind of production and purchase date. But this brings us to the Beagle 5 beta. So the Beagle Foundation and the manufacturing partners, they did a pre-production version of this board that they sent for free to some 300 developers who have an interest in RISC-V. Myself, I am one of these people. That is a picture of the board I received with its chunky heatsink. And I think there were 5 of us in total within the FreeBSD community who received these boards. It's a different production version. So there's 2 cores. It doesn't have the GPU, and the notable kind of difference is that there is some of the devices are not cache coherent, whereas in the final production version, they are expected to be. So in terms of adding FreeBSD support for this, this introduces a new kind of complication. And we'll come back to this idea of cache coherence in the next section. Finally, the all-winner D1 board. This is the only, out of all that I've shown, this is the only one that's not based on a Sci-Fi core. It is, I think, also expected to ship this year for, again, kind of a more affordable price point. I think what's interesting about this board is that it ships with an old version of the hardware vector extension, which we're going to talk about in the next section. And it kind of suffers from the same level 2 cache coherence problem where devices in the L2 cache are not coherent with one another, and it needs a software solution to this. If you're interested in obtaining RISC-V hardware beyond just purchasing it yourself, there is an interesting program being run by RISC-V International. They're giving away boards to interesting applicants. So I think they expect kind of a project proposal where you say, oh, I want to do this or that with a piece of RISC-V hardware, but they have a selection including all of those boards I just showed you and some others. But it's free as in free hardware. So they'll send it to you free of charge, but you're expected to do something with it. But this could be interesting for someone who wants to try out FreeBSD on RISC-V and maybe has a specific kind of idea in mind for what they want to do. You can check out the link there and apply to receive a board. So next, I want to talk about ISA features and the standardization process and kind of what we can expect to see next from the RISC-V ISA. So the standardization process is run kind of like an open source project. The RISC-V spec is available on GitHub, and anyone can submit a pull request and have that pull request considered for inclusion. So for particular topics of the specification, there are working groups that are working on these subjects. For example, the vector extension, which is, the benefit of this is that anyone who is interested, any vendor, any individual who has expertise and is interested in this standardization process can take part in it. As things are proposed, eventually they get accepted and are frozen, and meaning they are not expected to change, and then they're ratified. And once something is ratified into the RISC-V spec, it basically means you can implement hardware on it, because that portion of the spec is not going to change. There might be additions, but the low-level behavior is going to remain consistent. The overall problem with defining your computer architecture in this way is that the process is very slow. So there are some things that, if it was a single vendor or kind of entity devising the spec, they might be able to come up with more quickly, but there are things that from a software or hardware point of view are needed that have not yet been ratified. So for example, these proposed extensions to the RISC-V ISA, the hypervisor extension, the vector extension, the bit manipulation, and the packed, I guess you'd say SIMD. I don't know exactly how you pronounce that acronym. All of these are proposed extensions that have been in progress for a couple of years now, but they're not ratified. They're not accepted into the main RISC-V spec, and they're not guaranteed to be unchanging. So this poses problems for both hardware and software. From the hardware side, you can't implement any of these extensions because you risk implementing something that will be outdated. For example, the Allwinner D1 board implemented an old version of the vector extension. And this means that, when the vector extension is finally ratified, their chip is not going to look like other chips that implement that. And software will either have to choose to handle that, or they'll choose to ignore it and it won't be used. I said it does have an impact on the software side as well. So Linux and GCC specifically, they have a policy that they will not upstream any of this support until they will not upstream extension support until that extension is ratified. So there is a large patch set for the Linux KVM support that has existed for, I think, 2 years now, and it's not changing, but it can't land into the Linux kernel because the hypervisor extension is still technically in progress. FreeBSD, we haven't exactly defined such a strong policy around this, but we aren't trying to support any of these extensions yet. So in practice, we have the same policy. What else is missing from the RISC-V spec? Mainly the things to do with cache coherence. So it might surprise you if you know about other CPU architectures that there's the cache management instructions in RISC-V are underspecified. There are ways to handle the instruction cache on a particular core, but other than that, it is kind of up to the particular hardware vendor. There's no way to flush the cache with a standardized instruction. You have to jump through some hoops. And in the same way, page-based cacheability attributes. So being able to say the page mapped at this virtual address maps a device driver, and we shouldn't try to cache that memory. There's no way to say that yet. So now that we're encountering some of these cores like the Beagle 5 beta or the upcoming Allwinner core that don't handle device memory in a coherent way, the FreeBSD side has to handle this somehow, but there's no standardized way to do this. So this is kind of posing a messy problem where we're depending on things that so far RISC-V has just been too slow to define. And I guess I would go further to say that most of the decisions in places where the ISA is underspecified has happened because one vendor decided how to do it and kind of others have copied them. So Sci5 has defined some of the things like interrupt controllers and cache controllers, and other boards have copied that, but now we're starting to see more hardware emerge and they say, well, we need to be able to do some of these operations. We need to be able to flush the cache somehow. How do we do it? And the standardization process is too slow to have an answer at the moment. So I think it'll be interesting to see how this goes. As I note here, the cache management operation has a working group, but it's still fairly young. The page-based cacheability attributes has a proposal, so that could emerge soon, but it doesn't help with the hardware that is being produced now. So eventually we'll reach the point where these things are standardized, and there will still be these older boards that don't conform to that. And I guess the hope is that it won't be too messy to handle this. So finally, I'd like to finish off with kind of like where are we going? So I think RISC-V has a couple of use cases where it has obvious value. So for this, as an ISA that can be implemented by anyone and extended in certain ways, it really makes sense as a replacement for kind of a customized ISA that large hardware vendors might come up with. RISC-V definitely makes more sense there because it removes the burden of, okay, now we don't need to define our ISA, we can just implement our RISC-V core. I think it also makes sense as a teaching and research platform due to the open source nature of the license. So the perfect example here is the Cherry and FreeBSD projects. That security work at Cambridge is kind of the impetus for FreeBSD's RISC-V port, and they're benefiting from it a lot because they can replace kind of their older MIPS work with new with a newer RISC-V implementation, and it's always going to be free for people to research on. But as a kind of competition to x86 or ARM or in the server space, is RISC-V, does RISC-V really have a compelling case there? I sort of think not yet, not at the present. Basically, there's going to be some years to kind of catch up with where the support for these other architectures are, and by the time that that work is done, does RISC-V do anything new or better? That's hard to say. So perhaps there are people who have perspective on this that would like to share it after the fact. But what this means for FreeBSD, well, we were an early adopter of RISC-V. The FreeBSD RISC-V port was the first to land upstream, even before Linux RISC-V port. And I think as this architecture evolves, it only makes sense to continue improving our support for it and try to, you know, we see these new hardware platforms coming out now, and it only makes sense to try to support them as best we can. Yeah. So that's all I had to say. Here are some of the places you can find information about this project: the mailing list, the wiki page, and the IRC channel. So I want to open it up for kind of questions or discussion now. I'm not sure exactly how much time we have.
So we're pretty tight on time, but what we can do is we'll go ahead and kind of start our break now.
Yeah.
For about 10 minutes, but we'll keep answering questions during the break. So we'll kind of mix the two. So if folks need to run off to use the restroom or something, they can go ahead, and then they can catch back up on the stream if they need to. So we'll go ahead and start the 10 minutes, but then some questions that I saw on IRC. One of them was from Warner saying, did you run into any issues with QEMU user mode on RISC-V?
I don't think there were any issues that were specific to RISC-V, as far as I recall, but I didn't do any real hacking on that. I just kind of tried it and said, oh, it works or it doesn't work. And then as Warner and Kyle were making improvements, we kind of saw improvements in the RISC-V, in the packages produced by the QEMU user stuff. So there weren't any specific RISC-V issues that I was aware of in regards to that.
Okay. Let's see. Alan Jude likes your calendar, which is not a question. And then there was a question on YouTube, which is Sean Webb had asked about the size of the virtual addresses that we're using and how it affects ASLR. But I believe currently I think we use 39-bit virtual addresses. Is that correct?
Yeah.
And I think that's what's, I know there's I believe there's a ability in the spec for 48-bit, but I don't know if anything we currently run on supports 48-bit except perhaps QEMU. Is that correct?
Yeah, that's correct.
Okay. So I don't think it's right. Yeah, maybe eventually, and to do 48, what we would have to probably start to do is come up in 39, because I think that's the only one the spec mandates. And then there's a way to kind of probe to see if 48 works or not using a separate set of page tables that work in that mode and see if it works. And then so kind of go from there.
Yeah, exactly. It's more 48-bit is more or less compatible and just with an extra level of page tables from 3 to 4.
Can we go see what? I think there's some more questions on IRC. They weren't RISC-V questions, they were other questions. Okay, well, I think we might be good. So let's use the rest of our time for our break. So next session is going to be a 14.0 planning. I'll talk a bit more when we come back at the start, but there will be a HackMD that we normally use, and I'll post that URL in a bit. But we're just to kind of give a little bit of a heads up. I'm trying to compare to previous releases. I want to have this kind of be more of a living document that survives across multiple dev summits. So I'm currently have been playing with the integration of HackMD with GitHub, and I've pushed the current version. And so we can kind of have commits that are almost like tags about what we discuss at different versions of this document at different conferences. So it's already pre-populated with what we talked about in November and some updates. And then we're going to kind of continue to work through it and annotate it and update it and add new things. But we'll get more to that when we come back. So I'll see you all in about 7 minutes or so. All right, hi all, welcome back. Make sure I got this side muted. So our next session is going to be a 14.0 planning session. This is similar to kind of the have, need, want sessions we've done in the past. So I sent the URL. I need to still paste it to YouTube. Let me do that. And auto correction is a spell. HackMD is a thing. So we're going to kind of go through a discussion where we talk about, what our plans of things to work on over the next kind of 1.5 to 2 years, because when 4.0 is tentatively kind of on track to come out. So we want to talk through things that we have kind of a few different categories, things that we have or something that someone already kind of has a patch or a version of. Maybe it needs some work to get upstream, but it already exists in some form or fashion. Things that people need is something that you don't currently have that's in FreeBSD, but you as a consumer of FreeBSD in some way, you need this for some product that you're going to ship. It's a missing feature or a new piece of hardware that needs to be supported. Then we have a want category, which are things that are a little more pie in the sky. Like it'd be really nice if I had unicorns and ponies. And that's where you can put those requests and want. And then finally, we had a new session last time when we held this session in November at the vendor summit, which is we've added a session for things we want to remove from the tree. As especially the last several years, we've kind of picked up the pace a bit in removing things from the tree. So we've added a new session for that. So as I mentioned right before our break, normally with these sessions, we start off with a clean slate every time, and then we kind of duplicate some previous entries, and it becomes hard to kind of keep track of which things got done and which things didn't. So for 14.0, I'm trying a different approach for this, which is I want to have the same document that kind of survives throughout 14.0's kind of lifetime as head, and that we update, noting when things get done and when they, kind of the progress of things as we go along. So I took our version from last November, earlier this week, and I added some updates to it, noting which things had already been merged or trying to update owners in some cases for things that I knew someone was actively working on. And so some of it's already pre-populated, but from here on out, we're going to spend the rest of this session just walking through this list. We can either update the state of items if there's items that need state, or we can add new items that people are working on. So let's get started. First, let's walk through the have list and see if there's anything people need to update about the current have list, the state of things that they want to talk about, or if there's things on the have list that people need to add, that's new bits of work they have that they want to merge into 14.0 and kind of have sitting in a tree somewhere. So Ed is going to help with, I think Ed is sharing his screen so we can see the HackMD as it gets edited live as we walk through this. We're all going to collectively keep an eye on chat. So folks on Zoom, you guys can type questions in. You can also raise a hand if you'd like to talk. We'll see if that works. You're also welcome to ask questions on Discord or on IRC, and we'll keep an eye on those.
And one comment brought up on IRC is that everything that goes on here needs to have an owner, and this isn't necessarily the person who is going to do the work, but someone who is responsible for tracking the progress of this item and shepherding it in. The sort of, the flag waver or project manager for the specific feature, essentially.
Yes, nothing goes to list without a person. And then we can bug later to go, hey, what's up with that? So looking through some of these things are already been committed. There's not really much to talk about there. I don't know. Let's look at the stuff that's already on the list, I guess, and walk through them. Ones already committed probably don't need more discussion. The ones for hole punching for vnode, I know there's a set of reviews. I listed the first one for this, but there's like a stack of 7 or 8 reviews because it touches several different things as a new syscall. I don't know if there's more work for that other than to say that it's in progress.
One comment, John, on the items that are already committed. We don't want to go through them in detail here because it'll take too long. But one thing we may want to do is if there's any of them that folks know are missing documentation or following on from the release note discussion that we had yesterday, if there's any of those sorts of things that we know are needed for any of these or are going to be a significant amount of work, we might want to make note of them.
Yep. I mean, it might be good to even see, compare this list against Rail notes.
Yeah.
Periodically, and if something's not missing, then you need to explain, figure out why.
Yeah.
If they're not worthy or not. So I think the hole punching thing is in progress. ARM64 support for Beehive. I know there are several different folks working on this. The folks at UPB have a branch, and they have a open review, which I should tag over in the third column for this. And Andrew Turner at Cambridge has also been working with their patches and has some other additional patches that he's been using to test. So I know that's in progress and it's not committed yet. Might be good to add the link to the reviews. So in particular, the third column, we can either do when it's committed, you can have a link to the commit or a link to review when it's review, or if you just have a patch somewhere, if you want to, it can be any link to kind of a patch. It could be a patch to like a GitHub tree or something like that. Morello support, that's a big thing. You don't need to get in more into that. My branch about standard IO, I do have a GitHub branch I can point to, but that one's held up more on fixing ports issues, particularly GNU-lib. So this Cha-Cha 20, I got all the bits for that upstreamed into the kind of the base crypto layer and for KTLS, but there's also interest in using that protocol for IPsec. I can't find the review. When I looked the other day, I believe it was from AE, had a review that had a bunch of IPsec changes in it. It included the Cha-Cha support among several other changes. And I think the Cha-Cha support was like 2 lines of code or something like 2 lines in like 4 places. So I know that exists somewhere. So I just need to try to find, if I couldn't find the review, but if someone knows of it and can add the link, that would be really nice. Alan, did you want to talk any more about IPMI attachment for ARM64? Trying to find Alan somewhere. Other than still needs a bit of work.
Oh, hi. Yeah, it was some work that got started, but then kind of got put on hold. So if people are interested in it, it's most of the way there and just needs a bit of cleanup. There's comments and I think it's actually a series of like 8 or 9 reviews. Each of the separate commits is a separate review from Mark's tool. But it's most of the way there and it seems to work, so it works, but some users are reporting that the IPMI device stops working after a while, and we haven't managed to get to the bottom of that yet.
Okay, well, that could also be just flakiness of the BMC. Like
yes.
That would not be the first BMC that was flaky. So
yeah, and so being able to test on a slightly wider set of hardware, and with even just different firmware revisions would be helpful in that case.
And so for ARM64, is it using the normal, or is it using the same kind of transports or kind of protocols we're talking to the BMC that x86 uses? So for example, are you using the existing KCS code and SMIC and so forth?
Somewhat, a little bit of it is different. It also, like in this particular case, I think it attaches via ACPI or something. I don't know. There wasn't that much new code. It was mostly about finding the offset in a different place than you find it on x86.
Yeah, because the IPMI driver is like split into, it has 2 fan outs. It has like 3 different ways on x86 that we find it, and then it has different drivers for different back ends. And so if all you're changing is kind of the front ends for how you find it, it seems pretty low risk to merge, even if it's not perfect on some. I guess I would say if you haven't changed the back ends and you're seeing flakiness, that's probably not the problem in the driver, but probably a problem in the hardware that you may not be able to fix.
Right.
So I wouldn't want that to hold it up. The next one on here is hardware accelerated SHA and ZFS, which also has your name. So I'm going to hit some ones that have your name while you're here.
Yeah. So that one's not contributed by me. That was contributed by a contributor, Jeremy Faulkner or something. But I've been, I don't know, he's attends my local BSD user group. And so I've been deputized to help land it. So in particular, the there's a set of patches to the ZFS side, which will go upstream in OpenZFS. But first, some bits in Open Crypto need to land so that ZFS can take advantage of them to actually do it. And need some help figuring out what has to happen there. It's mostly changing an if having to do with when you use OpenCrypto to do the SHA of it, and you're not doing it as part of encrypting something. It's a little over my head.
Okay.
But I'll get a Fabricator review of the FreeBSD side of it posted, and that will probably help move it forward, because right now the patch in Bugzilla is both the FreeBSD and the ZFS bits, because you can't really test one without the other. But a final commit would likely be just the FreeBSD parts of it, and then we'll upstream the ZFS parts via OpenZFS and pull it in via the vendor branch, or etc.
And then you had one, skip a couple down, the KVM clock one. I know that's kind of in progress.
Yeah, so that's in progress. But what we could really use is help testing it in lots of different configurations. So this is if you're running FreeBSD as a guest under KVM, which most VPS providers like DigitalOcean and Vultr and all the others are, then this driver will make your clock faster and have less drift and so on. And so to support testing it, we made a ports kmod for it that will run on like 12.2 as well as 13 and current. So the actual review has the VDSO stuff and a bunch of libc changes as well. And the kmod doesn't include that, but it gives you at least half of the benefit. You get like a 10x improvement instead of a 100x improvement. But we'd really like people to test that and have some hours on it before we land it in head. And then maybe someday we can make a Beehive backend for it as well, so that we can use the same precepts to have a fast clock in FreeBSD guests running on top of Beehive.
Yeah, and actually I talked to Peter about that a bit, and I think he thinks the individual whose name escapes me who's working on it might actually be working on the Beehive bits as well.
I think so, yes. Adam Fenn.
Yes, that's the right name. Okay, so let's move down the list. The next one I have is from Warner, which is about NVMe error. Well, actually, Brooks, did you want to say something? What did you want to say something earlier about Cherry, for example, that I kind of glossed over?
Well, I think we're interested in the possibility of upstreaming our changes for supporting Cherry on ARMS Merlot boards, and we'd probably do RISC-V as well. I think the question is a matter of timing and whether we can get funding, because the changes are large and would require extensive review.
Yeah, I'm well aware of a lot of the thoughts about that and the scope of what kind of changes we can do. I know from our end and Cherry, we are trying to find ways to minimize our diff on our side, but also upstream the things that we can that make sense that aren't necessarily Cherry specific up as first, to kind of keep that diff as small as we can, but it's still rather ginormous.
So yeah, I think that's what I had.
Okay. So let's see, going down the list. I think next I had Warner to talk about NVMe error recovery. Do you want to say more besides what you have on the wiki on the HackMD right now? And if you do, raise your hand and we'll let you talk. Oh, go ahead.
Okay, so I was just going to say that right now the error recovery is fairly primitive. If we can't reset, bad things happen, particularly on commodity NVMe M.2 boards. And the error recovery will make it so that we can recover more often. There's two bits here. One, there's a couple of races in the review. And also, I want to do a function level reset if the card level reset fails. But that's it. It'll just make NVMe drives more resilient in the face of being crappy and under high load.
Okay. Let's see, the next one we had in have is work that Gleb Smirnov is doing with IMPCD synchronization. Did you want to say more about that, Gleb?
Do you hear me? Yeah.
Yes.
So just a quick status update. So so since we moved to the epoch to synchronize stuff in the network stack, there is some concerns that the allocation free traffic of PCBs is too high for the epoch to handle. So particularly at Netflix, we don't see this as a big problem, but because we have long lead connections. But in general, so we discussed this with Jeff, Mark, and others, that Epoch should protect things like interface configuration, address list configuration, but the stuff that is allocated and freed at a high rate needs to be protected differently, so that you don't need to do this Epoch callback to free every particular item. So I got my private branch where this switches to SMR with lots of different rewrites, lookups, and cleanups all around the PCB code. And it's in the progress. So that's pretty much of all of my status update.
Okay, thanks. All right, so looking at the have, I think the last one we haven't talked about is work from Ruslan working on GPU support for some ARM GPU cores. I don't know if Ruslan is on. Oh, he is. Do you want to talk about that, Ruslan, or is what is there sufficient?
Yes, should you hear me?
Yes.
So I developed support for the ARM Mali GPU, which is a Panfrost kernel driver. And I developed it on Rockchip RK3399 board, which is ARM64 board. So this project largely depends on the DRM for ARM64. And I have upstreamed a few patches to that DRM ARM64 project, which is called DRM sub3, and Manu is reviewing them. We, I think, have one chunk left for the DRM sub3 before I can submit the Panfrost kernel driver to review. So I tested it with HDMI monitor, and it works very well, providing 60 frames per second on a full HD resolution. So things works quite fast. I developed it on, I tested it with Wayland and S-Way compositor, as well as we tested it with a bunch of demos from Mesa project, 3D OpenGL demos. So this is sponsored by the UKRI. So I developed it in the Cambridge Computer Lab for the upcoming Morella board, and which will have the ARM Mali, similar ARM Mali GPU. We don't have a board yet, so I had to use Rockchip RK3399. So yeah, as I said, it works well, great, and we only need to have DRM sub3 in the kernel before we can commit the Panfrost. So that's it.
Okay, thanks for the update. Andy, I know I kind of glossed over Beehive and ARM64. Did you want to talk about that? Or is there something else you wanted to talk about?
No, I can think of. It's just we found some issues. I found some issues with the UPP code, that they do things like allocate. We have a lock held, I think, and or can't allocate, we can't state. That I would been fixing. But I think it's mostly identical, or it shouldn't be too much different from what we've already got in review, other than a couple of jobs pretty much rewritten. I've almost rewritten it.
Okay, one
I
question.
think if people do
Okay.
was we might want testing soon.
Okay, is there like a branch people can pull to test easily?
Yes, we've got one in Custard Cherry. We've got FreeBSD Romano branch I can point people at.
Okay, maybe add that to
It doesn't.
package when you get a chance.
It doesn't currently contain some of my recent fixes because I haven't pushed them yet.
Okay. One other question I had about the review is, do we think we can, right now it's kind of one giant review, which is really hard oftentimes for people to get reviewed. Do you think you can maybe pull out some smaller bits in advance and kind of split it up over time into smaller chunks that we can work on getting merged?
I have been doing that with some of the PMAP changes.
Okay.
So we've got support for two-stage, the two-stage page tables already, and so I've been trying to get things in that aren't necessarily or are needed by Beehive, but aren't necessarily under the Beehive directory. They're related things.
Okay, that's fair. Okay.
And we probably still need more work on the user space tools. I've got a very hacked up version.
Well, I think it's fine, for example, if you merge some of the kernel stuff, even while the user space stuff is outstanding, just because, carrying disk for a long time can get a lot of, if we're headed in the right direction, it might make sense to merge some of like the kernel bits if they're more set, even if the user land bits lag a while to merge, just so you're not going to carry as long a diff outside. Okay, so do we have anything else that anyone wants to add for Have, or are we ready to move on to our next topic? I'm going to go check of IRC and so forth. Okay, I think we're ready to move on to our next topic, which is need. I've asked a question on IRC. We can always add more haves if they come up. So let's walk through things that we need as opposed to things that I want. These are things that are a little more critical that folks really need in the next 2 years or so. And Manu, you're on like half of these. So if you're on the call, it would be really great if you, let's see. I don't see one IRC. Okay, so I'm going to proxy these by IRC. There's several of these that you have down as you, including DRM and base, which I would be a big fan of, for x86 and ARM, at least 64-bit x86, video for Linux and base, and USB video class driver. Do you have anything you want to say about those? Have you kind of made any progress on any of those? All still relevant and working on them. Okay. Okay, so they're still, so the status is kind of the way they are. What about, and package base I know is very much in progress. Is there another person who's working on, for example, Ed, are you also kind of working on package base along with Manu? Or is there another name we should tag there?
I am very interested in helping with package base, and I've done a little bit of work. Kyle Evans put in a fair bit of work iterating on issues as well, but I suspect Kyle is going to be fairly well occupied for the next little while. So I mean, I'm happy to have my name down beside package base for helping to track and find folks.
Okay. Then next we have a couple that Bjorn had added before. I don't see him on the call either. I know one of these at least is something that Foundation is funding Bjorn to work on. So do you have an update on how that's going? The 802.11 AC in particular? So
Bjorn's current focus is the driver side of things, and that's making pretty good progress. I expect there'll be a patch for testing imminently. The fleshing out the remaining bits of 802.11 AC support is a little bit more nebulous still. One of the troubles I think is that it's not really a binary. We have it or we don't. We have a number of parts of 11 AC implemented, right? So there's a whole bunch of individual things that are in the tree now, but I think what folks generally mean when they say this is the ability to have faster Wi-Fi speeds is really what this is a proxy for, and I don't have a good update on that.
Okay. The next one that Bjorn had put down was Thunderbolt 3 USB 4 support, which I know Scott Long has also looked at for a bit. I don't think he's working on that via the Foundation. Is that correct?
That is correct at present, yeah.
Okay, and you're not aware of anyone working on that?
I am not.
Okay. I wonder if we should annotate we didn't get a status update on a given time. Like with I don't know, like a question mark in the field or something.
Yeah, sort of a as we've last every time we go through this list, make sure that we have it.
Yes. Yeah.
You put it in the wrong spot.
Well, no, the third column might be the right.
Right, but I put it on the wrong item. But I guess the question is, we still need USB 4 support.
Yes, but we need it.
The question is somebody actually working on it or not?
Yeah, and is the right person still if they're actively working on it? I think in general, that's if we have an annotation for like not sure, got a question mark somewhere.
Yeah.
Okay. Beyond that, it's an Ed one. So Intel Skylake sound controller.
Yeah. So the this is why the microphone doesn't work on my X1 Carbon.
You just need an older X1 because it works on mine.
Well, I mean, in general, I think just always buy increasingly older laptops is not a viable path for.
I know.
I know.
Oh, come on, Ed. You're no fun.
Hey, as someone who's got a stack of X220s here, I am very familiar with this scheme, but no, there's a DSP in the audio path here, and to be able to use the microphones, you need to load firmware into this DSP, and it requires a newer HDA driver as well. I'm not sure if the newer driver is needed for other than getting the firmware loaded. It may be that loading the firmware is sufficient to make it work, and it's not a significant effort. But in any case, I haven't been able to look at it any further.
Hey, okay. Ed, there's a big pull request that I turned into a fab review that is for wiring of a large variety of HDA sound controllers. do we need, is that something we can put under your name too, or?
Well, I think that one goes under your name, Warner, because you're already almost like, you should could commit it already. I'll see if it fixes the fact that I lose sound when I suspend and resume my X1. But
I need a couple of reviewers for it to hit, yeah, it worked for me, if nothing else.
okay, I'll have to test it then.
Should I just add that as a line number so you have a convenient bug review on the need?
That's a have, by the way, isn't it?
That's a have right now. The original submitter is actually looking at ways for harvesting that data from Linux in a more generic way, but we might go ahead and commit what's there now. I'm talking to them as well.
Okay, I've added a. Okay, perfect.
I mean, we also, I think, are going to need to take a more holistic look at our sound quirk infrastructure, because it's kind of, I think it's not sustainable to keep growing that kind of list the way it's implemented. We need something that's sort of more easily maintainable for.
Well, some of that's what Warner was saying, is that they were looking at something to auto convert the quirks from Linux or whatever.
There's two. Ed's absolutely right. There's two pieces here. One is getting the data, and two is maybe publishing it in a form that isn't compiled into the module, or something we have to always update with the module. And that's also a fair point. The second one is not at all taken care of by the pull request.
Yeah, the pull request, assuming that it fixes people's actual issues, then that's definitely good in isolation, and we should make progress on that.
Why don't you and I be joint owners of looking for a victim, and I'll put that under one.
Yeah.
Okay. So I think the next, I pinged Manu about this DDC monitor control support, and I haven't. He says, I'm kind of looking at it, but he wants to redo I2C and Linux KPI first. So that's still in progress. The next one we have is OpenVPN DCO, and there's a link to what it is. And that's Peter Graham had that. And I don't know if that's a new one he added today, or if that was already, I think that may have been a new one he added today.
I think it's fairly newly added. It stands for data channel offload. It's basically,
I think I could let you do things like support KTLS, perhaps. Like OpenVPN now uses buffers and shoves buffers and OpenSSL back out, which breaks its ability to use KTLS. And so maybe this is a way to.
Yeah, basically, I mean, this is specifically this is a Linux implementation here that the link will be to. But it is, moving the crypto to kernel for OpenVPN. I mean, if we could join OpenVPN to KTLS, that would in effect be the same.
Yes.
The same effect. The implementation there is GPL'd. I had some early musings, but haven't done anything yet with pondering, seeing if the OpenVPN folks would be willing to dual license the implementation, so that anything we did need to use, if there is work in there that is not a direct analog to something that we already have, we'd be able to use it, but I haven't pursued that yet.
Okay. Then the next one we had was is a mini dumping a live system. That's kind of interesting, and that's Mitchell. So did Mitchell or Alan, either one of you, want to talk more about that, what the status is? Perhaps, I guess it's a need, so you don't have it yet. Is this something you're actively
Mitchell started work on it.
Oh, Mitchell started work.
Yeah.
Okay. All right.
Yeah, it's in progress.
Okay.
But yeah, I know previously some people had talked about code to just estimate the size of a dump while the system is running. I don't know if anybody ever got anywhere with that. But if you have that, we could use that for this as well, because we want to make sure you have enough free disk space before we try to dump the kernel. But we can recover if it turns out you don't or whatever. But yeah.
Okay, sorry, I'm trying to catch up on some backlog. Constantine asked me to put some things on the list that are needs. So go ahead and talk, Warner, while I do that.
Oh, okay. I was going to say I added camcorder to the haves. I need to. There's some polish that needs to happen, and I've based the current version on some speculative cam changes that either need to be made real or the dependency needs to change. But I'll take care of mopping all that up. I have it here so we talk about it next time more than anything else. And I had a question, which was, do we want to have any kind of dates or anything when there was a last status, or everything has a last status and just the one Thunderbolt 3 item will just have you just use the explanation point to mean in danger or something along those lines.
I think we can do that. So part of what I've done is HackMD has a way that you can push things to a GitHub repository. So to try this out,
gotcha.
I've made a little repository. For now it's in my land, but we can move it to FreeBSD if this works. That holds this file, and so we can push named versions kind of after each conference. And then over in Git, you can actually in HackMD, you can go and compare differences. You can see what happened in edits at different times. But in GitLand, you can look at it. It's in Markdown on GitHub, and you can compare the different versions and see what changes happened and kind of get a bit of do some annotate and history of lines. So I think that'll maybe fill some of that role. I mean, I'm hopeful. We'll see. So let me add these. So Constantine, he mentioned one about kernel TLS. I think it's about the ability to have the NIC handle receive offload. Right now for NIC KTLS, we only have support for transmit offloads. That's my guess for what Constantine was asking about. And then something called inline IPsec, which is like the NIC assists with encryption and decryption of IPsec packets. It's like the ability to offload the crypto to the NIC for you. And I'll just put those as needs because he said there were more needs than wants.
I think it is better to put NVIDIA instead of my names, or Keyboard Hans Peter.
Okay. Well, how about both of you? Will that work?
Yes.
Okay. And I've looked a little bit at the IPsec stuff myself. So, I mean, we should coordinate on talking about these things, which we will.
So the ones that we don't have owners on, I just added CED if you're interested to the TB3 based on IRC chatter. But it might make sense to, Ed isn't going to work on it, but Ed is happy to coordinate the people that are working on it. And maybe that could be an interesting, useful distinction here as people come and go.
Okay.
Does that sound good, or am I crazy?
No, we need to, this is a document for us to try to document things. So whatever makes sense.
And from IRC, one more item we had for the needs is the WireGuard module.
Well, it's kind of a have. Well, it's something. I'll let you categorize where you want to put that one.
I mean, at the end of the day, regardless of what it is, we need some sort of a defined strategy and approach, right?
Right. And there is code. It's a have. There's code. There's a port and so forth. It's about.
I guess that's true. Yes, it should be in have. It is a what do we do to make it real? Okay.
And you'll keep adding stuff too. So another have it looks like someone added is a 9PFS client. I think that used to be a want. It got moved up maybe.
There's a somewhat working branch on GitHub.
I'm aware of the somewhat working part of the branch. I just think
so I don't know. Is there somewhere halfway between have and almost have?
No, that's fine. It's fine.
It's at least as good as my camcorder stuff. It sounds like.
No,
mostly.
I think you can't have more than one mount, or suddenly things go boom. Is my understanding.
Oh. Okay.
Yeah. So can you hear me?
Yeah.
Yeah. This is Steve. Yeah, we have it at Juniper. You can do more than one mount. It's a kernel level thing. That's one guy in my team that's working on it. I'm trying to push him more to get that stuff upstreamed. So
okay.
And there's a lot of fixes that have been done internally at Juniper that haven't gone into that branch that he has up on GitHub. I've been trying to get him to do it, but we've been swamped with a lot of different things. But I'm going to really try to push him to get that committed.
Okay, I know there's other folks like at Cambridge. We tried to use it because we'd rather use that than SMBFS with QEMU, and that's where we found that it fell over pretty quick when using it. And then
there's a lot of fixes that we have internally that need to be added to that branch. So
yeah, we don't want to. Well, I guess I was getting at is we've been debating if we want to try to fix it or not. So it'd be good to avoid duplicating the work.
Yeah, one of the things that we were looking at too, and I put forward to him is with QEMU 5, which then now it's 6. There's a VirtIO FS which uses Fuse as the protocol. So we're going to look into trying to implement that too, or at least that we're having some discussions internally about implementing that.
Oh, that's very interesting. I've talked with Peter Greyhound about that a bit too. I think there's a couple other folks who are interested in that one because it has an optional kind of zero copy mode that will be really nice.
Right.
Do we want to put that on the need list maybe? Or sorry, the want list?
Yeah, I guess that could go on the want list, yeah.
Yeah, VirtIOFS should probably be on the want list.
I've participated in the Beehive developers call, and there's someone who has access to a pool of motivated students who want to work on this. I think 2 or 3 weeks ago. Are you in contact with them?
Larkin?
Yeah,
I think so.
We can maybe try to get folks to get, like I can maybe try to go between that.
Yeah, and I'm working on some stuff to try to get better visibility into what goes on in VirtIO itself. So it's because we had some things with VirtIO block devices and some other stuff about seeing if you get into this situation. In some cases you can, depending on which version of QEMU you're running, where IO operations on virt queues can stall. And it looks like if you're running older QEMU, like even some of the versions of 4, there's some issues with VirtIO having IO threads and where some of the virt queue stuff can stall. We've been talking, so some of our products use WinRiver Linux as an underlying host OS with a virtual machine thing that has FreeBSD based stuff in it. And we're working with WinRiver for some fixes for that on the QEMU side for QEMU 4 and earlier. They have some things that we're trying out, but as part of debugging that, it's very hard to tell what's going on in the VirtIO layers, especially because you don't have a lot of visibility. And even with dtrace, there's some points where you can't get visibility unless you either flag some functions as don't inline these, or you have to add static probes. So I have some static probes that I'm adding in various places so that you can still keep things inlined. I intend to upstream that. I'll add to the list for that. But I'm trying to do some tools to be able to watch the IO operations that are happening on vert queues, which is really handy since a lot of things are using VirtIO in the QEMU case, and you often can't tell why did something stop. So I'm trying to improve that situation. So there's a sort of a kind of have, sort of want. It's gonna, you know, there'll be things coming in the future.
Okay. Let's see where we're at on. So we've added some more things up top, but I'm going to let them set because I think they kind of already have status. Do we want to go ahead and move on to the want section? Use our remaining time to talk about wants, and then we have a bit of things to remove at the end that I don't want to skip because it's always a good day when we get to remove code. Although some of the wants are actually things that need to be in the X. But so eBPF, if I could talk. I think this was from November. So Hiroki, do you have an update on that one perhaps? Or is the current status still accurate?
Can you hear me?
Yep.
I have no progress so far, but I discussed several people to how to import the eBPF functionality into FreeBSD. The one big problem is the eBPF VM itself is easy to import, and we can have the extended instruction set to improve the current BPF, and we can have some hooks to run the eBPF program, and we can load the eBPF program from the user line to kernel. But the big problem is how to use the eBPF program, because most of the eBPF program for Linux heavily depends on the internal structure of the kernel. For example, the software-defined networking depends on the Linux SKBUF structure. So we are using MBUF. So if we want to use the Linux program in eBPF, we need some translation layer. And for other so other programs like seccomp or eBPF applications available for Linux also have the same problem. So just having the eBPF VM is not so useful if we aim to have the compatibility with Linux. But if we explore the application, our own application, eBPF will be useful to implement the some autonomous circuitry inside the kernel. For example, we have a bridge which is run by the eBPF program under the kernel without the interaction with the current network stack, for example. So for 14th release, we still need some discussion about the implementation, but the importing itself is easy to do. That's all of my comment about this.
Okay. Thanks for the update. Alan and Warner, y'all are next with fail-safe boot code.
This is part of what we discussed in the working group earlier. Okay. So part of this originally was the boot once and next boot support for ZFS, which is done, but we still need to make it so that updating your boot code doesn't risk you needing to use a USB stick to fix your system.
Okay. I mean, I appreciate the working next boot on ZFS since I use next boot a lot. So
yep.
At least next boot minus K. An SMBFS client for a modern version of SBFS. I believe this was on there from before.
I think so, yes.
And do we, let's see. Oh gosh, I can't remember. Do we have a status update on that one?
I don't know if Matthias is here or not.
Okay. Maybe we can put a whatever our status for like a question mark to say we don't know. The status is not updated. Then Warner, so this next one, I wonder if you remember what this was. Axiata had given a talk last November, and so you added an item for better auto-tuning for things like read-write caching. Do you remember the context of that exactly and what that might be?
No.
Okay.
TLDR, no. I think it was different. I can't remember if this talk was the, hey, we need to tune the buffer cache parameters better for larger memory systems, or if this was an OpenZFS thing saying we needed to tune the knobs better for that automatically. I've lost track, unfortunately, of that, and so maybe
we just trim it as kind of not actionable if we can't remember what it is.
Let's kill it.
Okay.
I mean, unless somebody on IRC says, "Oh yeah, I remember that," and they want to put their name there, let's kill it.
Yeah, if somebody wants to go watch the video from November and figure out what it was about.
We can always re-add it if someone is motivated to work on it.
Indeed.
But we'll end up in the same, yeah, go ahead.
Yes, this is the problem we have with Bugzilla, right?
That's literally the words that I stopped myself from saying. NPF, so George, are you around to speak? Oh, I don't see him on the Zoom. I don't know if he's still working on NetBSD's firewall because we don't have enough packet filters in the system. Don't see him on IRC. So I'm not sure if that's one he's still working on or not. And I guess actually we'll mark all of George's for now, kind of a question mark, like in need of status. And right, we will, someone asked on IRC, we already have a legend for some things, but we might add for the new annotations we're adding today, we might need a little key to say what they mean. Yes, Jeff is not here to talk about ZFS ARC and VM page integration. NP-safe sysctl handlers. I think the status of this is about the same as it was last time, which is the bulk of the work down to the first pass is done. But I don't know if we made any recent progress on figuring out, are there ones that are currently marked needs giant that aren't, or not marked needs giant that are not marked NP-safe that can be marked NP-safe. I think that's the kind of long tail of this, and I don't think it's changed since November.
Yeah, I think a few things have been committed to make it better, but not to materially affect the status.
Yeah, I mean,
the long tail is a little shorter, but it's still pretty long.
Yeah, and like the main infrastructure work is done, I think. Maybe the only thing is at some point, it would be nice to start flipping some of the sense of the flags to being you opt into Giant instead of opt out of Giant, like we do with CDEV switch.
Right.
One day I'd like to do that with interrupt handlers, but
we started that work as well as part of the MP safe is trying to mark enough things as basically mark it both ways, and you have to mark it one way or the other. And once we have everything with
mark one way or another, then you can
mark one way or the other. Then we're going to kill the MP safe throughout the tree. But yeah, there's still too much, and there was some resistance even to that plan. I think that was taken care of, but I'm not sure.
No, I think it's still, I don't think we've switched to annotating Giant instead, but I don't think it's actively being worked on.
Okay.
So you're up here, and some of these maybe should go, well, they're kind of axing things, but the next four are you. So do you want to just talk through them?
I'll just talk about them briefly. And, you know, it's basically the next three are kill Giant. There are two big users of Giant right now, the keyboard system and NuBus, and a few others. It's weird where you find it, that would be relatively easy to mop up. And the two big pieces of work here are making NuBus not need Giant, which isn't terrible. But you know, it's fourth on my list of things I have time to do two of forever. And the keyboard, AT keyboard and USB keyboard and all that, detangling that so that DDB and friends still work. It's a piece of work, but might be easier now than when this was on the list, you know, from years ago, simply because we have better, we don't necessarily need to do locking to do this, to get the concurrent access protection. And so I think this might be a good case of somebody looking at it hard and being able to do that. I don't have time for that. And then the fourth one, maybe we want to take it off the have, need, want for 14, because I think it's probably too ambitious.
Okay.
I don't think we're going to get to that. Just, there's not enough, it's dependent on the other things, which I think we might barely get done. And it'll be a piece of work once those are done, or at least the strategy is set for that. So, okay, it's gone.
Okay.
So that's what I have there on that. We could potentially reword it, because a lot of this is, you know, move away from giant locking rather than just kill it. Once those two items are done, there's half a dozen other stupid things that are mop up that, you know, could easily be done. But until the new bus and keyboard driver are fixed, we've got some issues.
Okay, so I'm trying to watch our time here, and we may go a little bit over, but let's kind of move more quickly, especially through things that are old and already existed. Looks like the Panfrost support is something, for example, we just talked about that's up in the have now, so we can probably kill that one. George is not here. Move more of if config. I think some of this is still in progress. I think I've seen some commits since November. And yeah, we don't have I don't know if the person for gel cuddle is here.
I don't know if that's Ryan something, right? Oh, is it for gel CTL? I don't think they're here now.
No, yeah.
And
Okay.
for if config, I don't.
Ryan.
Yeah, I don't know if Ryan is here or not.
Okay, Mitchell had a thing from last time about SVE on ARM. Do you have any more thoughts about that, or have you had a chance to look at it, or is it still kind of pie in the sky?
It's still in the same place as when I added that, but
okay.
It is still on the list of things that I want to do, and kind of within Foundation scope.
Okay. All right, the next one, Baptiste or Manu. Manu already says his mic doesn't work. That's very convenient for this next item. A brand new shell? What are these people like? Oh, nuts. Is this a joke, or do you still want to keep this one? I know Baptiste mentioned and that can be removed. Okay, good. All right, we won't talk about this anymore. XFAT, there is an active review for this. I don't know if it's had much recent activity, but I did add the link to the review when I was looking at this earlier this week. So that's, I think, the status of that. I don't think Conrad or Chen are on this call. Suspend and resume for ARM and RISC-V. This is also a Mitchell request. Do you have any thoughts on that one?
Am I still on the mic?
You are now.
Okay. It's still no progress.
No worries.
But yeah, it is something I'm interested in looking at on the side.
For RISC-V, is there? I mean, normally suspend and resume is a bit like it's not something you do in an emulator. You kind of need a bit of hardware. Or is there a particular piece of hardware you're thinking about targeting for that?
No, not with what's available now.
Okay, like I didn't know if the Beagle 5 plans to have any kind of reasonable power management or not. Because another way to think about this might not be just suspend and resume, but especially the time to the next one, it's just kind of, even if it's using less power and you don't go fully to sleep, but you have the ability to start turning devices off and kind of do power management, that might be the even better way to really think about this one.
Mm-hmm. Yeah, I've seen some like there is some proposals for how this kind of thing will be done on RISC-V, which is kind of why it's added there. But yeah, it's a larger item that will require some thought, I think.
Okay. So the S0IX, I know I have not looked at this at all. We could at least maybe add a link to Ben's earlier branch that he had that's still on GitHub, but it would need some rebasing and someone would need to apply some love and care to it. SDIO, and I believe maybe someone, Manu, can you speak to this next one? This item is on me. Okay, so we're reassigned. Do you have an update to it? Is there a branch or review or anything like that? He has it working. Ooh. So this is a have. This is not a. I'm going to slide that up.
Yeah, I was going to say, I thought it was in the wrong place. I'm glad Manu jumped in to say that. Because I've been helping him tidy up a lot of the CAM parts of that.
Okay. And apologies if my audio, Sai said something, and I know my internet was having issues earlier when someone else was talking. So hopefully I'm not sounding like I'm talking through a big batch of water or something.
Seems okay here.
Okay. I think we're getting almost close to the new stuff. Ice Lake PMC. This has Alan down as a responsible. I think this was from last time.
Nope, this is brand new.
Oh, this is brand new. Oh.
Yes. So NetApp wants the hardware PMC stuff for the Intel Ice Lake. It's just, I think, adding definitions and stuff, but it's something that is wanted. And if you're also interested, please get in touch.
Alan, do you know if there's anything fundamentally different here? Mitchell is working on updating the PMU events, and I'm wondering if this will just come for free with
possibly. Like I looked into it a bit, and so the commits in Linux aren't clear about licenses and so on, but there's original stuff from Intel where there's a bunch of JSON files that are dual licensed.
But it's just the data update that's needed, really, right?
As far as I know.
Yeah, okay.
I've seen Alexander's diff for this, and I don't think that that's in upstream Linux yet, but it's more or less the same. It's just new JSON files for a different CPU ID.
Yeah, yeah.
Okay. My question there is, does it make more sense for us to come up with our own tools or be able to ingest the JSON files from Intel rather than whatever the Linux people do to it to make their version of the JSON files? Like the files that go into Linux come through the perf project where they get put into a format for their perf tool, and it's not the data as it comes from Intel. It's reformatted to like one file per something instead of.
I mean, so there was a bunch of work done a couple of years ago to make FreeBSD use the perf formatted JSON, and moving away from that seems like a lift. That
right, but as long as somebody made that decision at some point, then I'm fine with it.
Yeah.
It probably has the advantage of applying to things other than just Intel, whereas going to the Intel one wouldn't too. So,
yeah.
This is probably a topic that we could have a working group session on at some point as well. A little later, I bet you it's something that there's enough interest in that we can do a broader discussion.
Okay. Next one is Linux. Linux like AB binary support on ARM64. I know this is something that Edward is looking at Cambridge, but I don't know if he's looking at the ports side. So I'm not sure what the ports testing mean. And I don't know if we have, I don't know if, I think he's running binaries. I don't know, do we have ports infrastructure in place to have, like, for example, a compat Linux metaport and the associated ports for ARM and ARM64, or at least ARM64?
Yeah, so I chatted with Mark Lindemann about this a little bit. Basically, I think the issue here is that the ports infrastructure essentially throws up its hands and says, Linux Simulator only exists on x86, and it just I don't remember if it's broken or if it's skipped, what the case is. But in general, any port that says it uses Linux Simulator gets disabled on ARM64. And I mean, I think there's I think that the actual changes needed in the ports infrastructure to support this is extremely minimal. It's really just a long tail of testing and fault finding.
So should this item really be about not the base system, because that's actually, I think, mostly committed, and aside from like additional fixes to get it working, I think that's is this really about just the ports? And should this line item just be about making use Linux equals yes work with ARM64?
I think so. If anyone in IRC has a difference of opinion, let us know. But
you might want to add also the CentOS ports or whatever, the thing that installs the RPMs of that gives you a Linux base system.
Yeah, I think that's part of making this work.
It's again part of the ports. I think it's more than just fix the ifs in the MK files that say
yeah.
But in particular, I don't think this refers to changes in like the kernel. I think this is more about adding the right infrastructure and ports to support ARM64 Linux binaries.
So Edward,
does that change the owner?
Yeah, that's what. Yeah, Edward is not the owner for that, so we're back to needing a victim.
Edward has a queue of fixes for the base system for this, but generally speaking, I think what's in the tree is generally working, and there's not a high level item we need for the base system. It's just a set of bug fixes. This really is ports infrastructure and ports dependencies.
So I'm seeing quite a bit of chatter on IRC. I don't know if I've seen anyone volunteer to own it.
I have a suggestion on who we could volunteer or voluntel or whatever. The Vincent, the guy that's talking about ARM64 virtualization tomorrow. He seems to really like making ARM stuff work on FreeBSD.
And do you have his last name? It's on the schedule.
Yeah, he's speaking tomorrow.
Yeah.
But
this is Vincent, right?
Yeah.
Okay.
But that said, I mean, I'm also happy to have this parked with me if necessary.
I will never turn down the ability to add your name onto something if you volunteer. Remember, and I'm going to move on in the interest of time. We're going to run over maybe 10 to 15 minutes and then do our break. So we're going to aim to kind of wrap up here in the next 10 minutes. Remember original interface name. This was an
yes, if config name to rename an interface, being able to tell what it was originally called.
Oh, yeah. Okay. And you have a review for that. So that's a have, isn't it?
Well, the review is stuck in the fact that ePair interfaces are strange, and we need to come up with a solution to the problem.
Okay, but if you have a patch, it's still really a have more than a...
Yeah, but it doesn't work, so it's not really
I have but broken. Okay.
I have lots of halves if broken patches count.
Yeah, you need a section for that. I mean, my standard IO file one is basically in that column. Detach BPF from IFNet. We kind of talked about this yesterday. And I think during camcorder we talked about this more. I wonder if we still want this in this fashion, or is this a cleanup of the thing that we currently have that works kind of now?
I'm not sure why, Gleb. Go ahead, Gleb.
I think what Warner is doing, if he's doing that faster than what I want to do, not a problem. So let's do it even without the camcorder. I think it would be a nice feature to have BPF tapping points anywhere in the kernel, and at a glance it seems fairly easy, And I think with the camcorder coming in, it just should be done. But again, since Warner already has the working version, it's fine if the working version of camcorder goes in first, and after that we do a complete diverse of BPF and IFNet, so that you can tap on IP input, or you can create the IPFW rule, very specific, that will give you a stream of BPF packets so that you can run TCP dump on 100 gig interface without disrupting the performance of the machine, because if you're interested in a particular host. So there are multiple applications for that, and of course camcorder too.
Okay. Then you actually have the next one as well, Gleb, which is organization for NetGraph.
Yeah, so I put this into the want item because I'm not able to be the main driver of that, but looks like we have new committers, Lutz, I hope I pronounced the name correct, who is interested in NetGraph, and other guys are also. So I think the time has come to review the synchronization, because the regional synchronization actually predates the mutex KPI in the kernel. So the NetGraph has its own login, very, very specific, and it has had through the last decades, it has had problems. So there was a topology mutex introduced, global one, and this topology mutex, to close different panics, the topology mutex were used more and more, and now it effectively becomes like a small giant inside NetGraph. And now that we have the epoch, it seems to me that epoch suits the NetGraph very well. So the graph is a configuration that doesn't change very often, and if we just delay the freeing of the nodes, so just in my mind, it pans out very beautifully. And if someone is willing to work on that, I can help with that. But again, I cannot be the main driver of that.
Okay. Then some of these you've already talked through: SoundQuark system, VirtualFS. QEMU user, do you want to say anything more about that, Warner, or is your description kind of already cover it?
I got nothing to add in the interest of time. If you're interested in helping, get in touch.
All right, then the last couple of minutes we have, I just want to spend time on this kind of Axe candidate section. Are there things that we need or want to remove from the system? And do we want to talk about them? The first one we already have here is FireWire. So, and that has Warner's name next to it.
Yeah, I'd like to get rid of it. Mostly from a CAM support point of view, it's kind of crunchy and it's not very relevant. But every time I talk about it, people say, oh, but I use it for debugging. So I don't know.
I mean, but you can't use it for debugging on a piece of hardware that was made in this decade. Well, I mean, I guess this decade is short, but even most of the previous decade. And I mean, I must say that my solution to the debugging problem is you use a VM and you use a debug server inside your hypervisor, and that works a little better for things like device.
Okay. So I guess you're suggesting that I not let that be a blocker and I start a full discussion on Arch?
Yeah, I mean,
that would be the
let's
next
make sure
step.
there really are people who are using it as the kind of remote debug target security hole that it is. But make sure that it's not just a paper tiger.
Yeah, I would hate for the situation to be folks saying, I don't want this to go because I could use it for debugging, and no one actually is.
Yeah, because you can't actually use it for debugging on anything that's made in recent memory.
Yeah.
Yeah, I tried a little while ago to use it with PCIe add-on card, and there were issues. So.
Okay, so let's get to the bigger ones. ARM v6.
Yeah, this is the old, since Mono doesn't have a microphone, this is the old Raspberry Pi original board and the Pi Zeros. We've kept support in place for those because, you know, it's convenient for users, but it's also kind of a pain in the ass because we have another set of packages and another set of interfaces in the kernel that have to keep working, and some grumpy ARM maintainers that don't like to, you know, do that. So it's up.
Do you really think you're going to do it? Like, what do you need to do for a next step?
I think that the ARM folks need to figure out, can we commit to supporting it for 14 or not?
Okay. Next up are some of the things Kirk lamented yesterday, along with Telnet-D, which Telnet-D versus Telnet, that's an important distinction. I think if you get rid of the Telnet client, you'll have pitchforks in your yard. But Telnet-D, RLogin, and RSH. Is anyone driving this or looking at this?
I didn't realize my name was beside this. Must be left over.
It's the beauty of these things.
I know Adrian had wanted to keep Telnet-D because SSHD is too big for routers where you only have 16 megabytes of storage or whatever, but I don't know how much we care about that. All the R stuff should be nuked from orbit, I think, right?
There's also this this wonderful API in libc called rcommand, rcmd.
Yeah.
Which like invokes executables as root. It's outstanding stuff. You should look at that and see if that can be deprecated or not, or if we can have compat symbols that just always fail or something. Yeah, the rcommand is special. And there's some other related APIs, like one that says, is the remote user trustworthy as root or not? Which is, the correct answer is no, but it doesn't actually always return false. So, okay, number next.
We got a hand up.
Oh, sorry. Go ahead.
Yeah, it was just in regards to further up where the wants section was. I think I raised this back in 2017, and it's for Christoph. He probably doesn't want this. It's uplifting the PF code or the syntax really to bring it in line. We like the upstream PF syntax has been around for 11 years now, and from an end user, a lot of people are having to manage two branches of PF rule sets when they've got a split environment. So it's just if we could bring that in line with upstream, that would be much appreciated.
Okay, Christoph will hate me. I'm waiting for the screens. He hasn't noticed yet. Okay, I'll put that in as a want. And then, let's see. Oh, Christoph wants to talk. I don't know if I want to allow Christoph to talk. Okay. Go ahead.
Yeah, so I realize that users want this, but I want someone to do the work because I'm probably not going to. I have 0 spare cycles as it is. This is a huge project, and we can't just take OpenBSD's PF without a massive performance regression, which A, our users don't want, and B, I don't want.
Okay, well, I've marked it as needing an owner because it seems like it's more, I think Jason's ask is supporting the same syntax, so it means probably re-implementing support for that syntax.
May I add just a few words?
Go ahead.
So Jason, 9 years ago, I have written an email about OpenBSD PF and FreeBSD PF, and today this email, I can send you a link later. It's still valid, and it's even more valid than back then. So basically, the time when the PF was first time imported into FreeBSD between forking of OpenBSD and FreeBSD was about 6 years. And today it's, I I believe, about 20 years. So the differences in operating systems are so huge that speaking about importing it as is basically impossible. Even the early port was very unstable. It was very unstable until I put a lot of effort into making it FreeBSD PF, basically. Yeah, yeah, that's it.
So basically, the ask is the same as make IPFW ingest PF rules. Right, it's a completely different firewall at this point.
I'm going to disagree slightly with that. But perhaps we should take this discussion to the hallway track after this.
Yeah, that's probably makes sense. Okay, just scrolling through. Let's see what else have we got on the axe list. In interest, let's see. Ed, are you going to remove the old SMBFS?
I think we should. I mean, I think it doesn't really serve much of a purpose. The protocol is well and truly deprecated and unsupported in most places. I mean, it would be very nice to get a kernel contemporary SMBFS available.
But that's probably orthogonal to this.
But I think it's orthogonal to this. Like, there's basically. I think that folks are either not using this or shouldn't be using this.
Okay. Trying to look.
It needs. I need to follow up on mailing lists and make it a little bit. Have a discussion. Brooks says he doesn't want SMBFS to go until VertiFS or 9PFS is available and stable.
Yeah, in Sherry we use SMBFS because we have to. So I'm aware of that. I'm not going to say anything about MIPS because we don't have enough time today to have a productive discussion in that department. The ARM one, I think, is similar to ARM v6. I think they're really the same thing. Like ARM v6 is just one of the SOCs to consider effectively because it's about specific SOC support. SynMail, Manu put this.
Yeah, let's do it.
Oh, he says no plan to work on that anymore. Okay, does Ed want to do this? And what is your plan for local mail delivery when you do this?
So no, I don't want to take this. I just want it to happen.
Okay.
But I can keep track of it if you want.
Okay, well, I think we'll just have a no owner. Let's be realistic. Bootloader 4th support. Warner.
I don't know if he's still here. I can only think of 2 people that would object.
He's not one of them. Okay.
Yeah. Actually the one of the people is Juniper, so we need to touch base with them to see if they need
yes.
The other person is very invested in it, and if they're the only person that cares, then it's probably best to let it go because a number of new features are being done as Duo only. So.
Okay. I'm just going to skip down to the ones that are new because like we're already over budget when I wanted to stop late. Brooks, you had put remaining ATM support. I thought we removed all the ATM support. We still have some bits we didn't axe.
There we are. Yeah, so there's still a libATM and there's some stuff in NetGraph. Or it's a libng ATM, I think, or something like that. So
it might be only NetGraph, yeah. Okay.
So there's a few bits that I suspect the NetGraph stuff doesn't actually work because there's nothing to connect the ends to at this point.
Oops.
So I think just getting rid of all of it probably makes sense.
Okay. Then Warner, you said obsolete cam drivers. So are you going to do like like a what's the name we call this thing? Effort? No, something. The thing Brooks did with all the NIC drivers. Are you going to go through that process?
Yeah.
Okay.
Yeah. Scott and I came up with a list a while ago, and I retired about half of them, and the other half didn't happen for various reasons, and some of which need to. So we need to just figure that out.
Okay. And then Manus has a slate of drivers he's trying to of old wireless drivers. Aranet is a weird thing. It will be kind of nice to get rid of that bizarre thing. Set key. What is? Let's see.
That's a MD5 thingy that Manu found that's used. I think that might be the same as NIS crypto. Honestly, I don't know.
I think no, the set key.
No, it's MD5, not DES. Manu's saying so.
Right, but is set key still used for the TCP MD5 thing that routers use? Because it's terrible.
Well, set key.
No, it's not.
Set key is not the right name for this. Like that's set key 8. This is something else.
Oh, it's public key 5, not set key 5. I wrote that wrong when I put it there.
So the only thing I would say, Manu, is you might want to do initial commits to mark them deprecated that you can merge to stable before you actually do the reviews to remove them outright. That's usually worked a little better for me in the past. Okay, well, it is 11:50. We've gone quite a bit over. Our next session is WIPs. Let's take at least 15 minutes, and we'll have to start WIPs a little late. Let's take at least 15 minutes. Folks have time to get up, stretch your legs if you need to, run to the restroom. And when we come back, we'll do our work in progress talks. If you signed up for a WIP, please make sure you're on the Zoom call so we can kind of have you staged and ready to go. And we'll be back in about 15 minutes. Thanks, everyone.
Like and subscribe to you. Like and subscribe to what?
Okay, that's the last of our alarms for today. So our last session for today is our WIP session. So we're going to have a series of short 5 to 10 minute talks from folks. And we do ask our folks to really try to stick to the 5 to 10 minutes because we have like 7 or 8 talks now lined up. So I'm just going to turn it over to folks to get ready. The schedule I'm going to try to follow is the schedule that's on the wiki page, and we'll go roughly in order. So the first talk we have is Kevin Bowling talking about network stuff, dealing with iflib and the Intel drivers. So Kevin, if you're ready, I'll hand it over to you.
Sure, I'm ready to go.
Okay, go for it.
How is the screen share? It's been a minute since I've done all this.
It's working.
Okay. So my name's Kevin Bowling. I've been doing, that's not what I want to do. I've been working on FreeBSD network stuff for a while. I've been away from it for about 3 years due to a job change, but I just noticed there was a large accumulation of bugs and wanted to get back into the mix here. So I just have like a meta comment about this whole situation, just so we can improve the state of FreeBSD networking, especially where it concerns these things. This is the iflib bug query, and this is the Intel networking bug query. I've been trying to go through some of these and just kind of make sure that we have like good triage and qualify the bugs. One thing I've found in particular is like there's maybe like 5 actual iflib bugs in here in this query. The rest of these are generally like driver bugs. And then on the Intel networking side, there's quite a few stale bugs in here. Like it's pretty hard to determine whether these things have carried over from the FreeBSD 11 and prior driver to the new one or not. So when I started, I think the bug count was probably like 10 or 15 higher. I went through and just closed a bunch that didn't look like they were reproducible or actionable. And then I've just been whittling through some of the other ones. And then the final comment is just when we're working through this stuff, I would like to see a precision in language when we're talking about the bugs. Like, for instance, if there's a framework bug, that's a different problem than a driver bug. And, you know, as operating system engineers, we need to be precise in what we're talking about. So in the vein of E1000, I went through and fixed a bunch of bugs. The first 3 had PRs. These were just, you know, going and finding stuff that was ready to go and getting approval from a source committer and adding it to the tree. The top one is show bad packets. This is like a debug feature of the hardware where you can see packets that don't generally pass the hardware criteria for acceptance up through the stack. For some reason, this was toggled on. I think that was just when we were doing the initial work, it got left on, and that should have never been in ahead in the releases. So thanks to Franco of the OpenSense project for that. There was another trivial bug where we had the wrong MacMin for lem. And a related problem to the buffer sizes, the packet buffer sizes. Jeff Gibbons found this. This is an extremely old NIC, but it was a trivial patch. So it's just like, why not fix that? So that is in the tree now. And then there was the IGB VF interface uses a random MAC if you don't assign it from the PF side first. It has to generate a MAC. So I just reincorporated this patch from, I'm not sure how to pronounce this name, Belev, PA. But that is fixed in head as well. All 3 of these have MFC'd to stable 13 and stable 12. Kyle Evans created a new interface for this random MAC to handle the case of like not having a host UUID. So I'll go through the Intel drivers and update all that to use the correct KPI rather than an internal implementation. Then this hardware multicast filter management was an interesting bug. JTL reported this like a decade ago. We didn't handle a bunch of boundary conditions correctly. Like the hardware has a limit of 128 filters. And when you go above and beyond that, you have to switch to promiscuous mode and then disable the hardware filter and let the BSD stack handle things. So I looked at this, then looked at IXGBE and went and stole the implementation from IXGBE. That is also in head stable 13, stable 12. I added support for the 3 recent or future client platforms from Intel. It's good to get those things in early because, you know, the FreeBSD release cycle is usually like 6 to 12 months out. So we want to get those things in as early as possible so people can run on new hardware when it comes out. A similar clerical thing is just improving the device strings. So if you do like a D message or watch your boot logs, you should see a much more useful entry for any E1000 drivers now. This is important because when we get PRs or when we're talking about bugs, we don't often get like a full package of information from the reporter. You know, you might just get like a D message or PCI conf L or whatever. The latter is more useful because you can tell what the MAC type is, but in the case we're not getting that information, it's useful to get to help the reporters understand what they're doing and that there are like, you know, 100 different MACs in this driver and all of them have interesting quirks. Then the final thing here, this 82574 is, it was kind of a straddled like a workstation / server gigabit Ethernet NIC like a decade ago. This was pretty common in like high-end like Mac Pros and super micro servers and stuff like that. At my previous employment, we added MQ multi-queue support to this. It can support 2 queues, and in the process of doing that, we missed a step of in the process of making it an MSIX thing. We missed the way that this handles link status changes. So I fixed that. And then while I was in there, I just cleaned up the general intent of link status changes for IGB as well. I've got a few things in progress for hardware VLAN filter management. This looks completely broken. Like, I don't think it actually works right now. I think like if you have the capability enabled, you're actually not getting hardware filtering. I have a pretty good handle on this. It's just a time constraint thing for me. Like I only get an hour or 2 at a time to work on these issues, and that's generally not enough to make progress on some of these bugs. But I will try and find some time in the coming weeks to finish this. This one's related, the TXRX cleanup. There's some you have to move these flags around for like IPv6 in the hardware descriptors. And that's different per MAC type. So the only way I knew how to do all this was just to go download like all the data sheets I could find for all of these cards, and then you know, try and make a table and figure out what's different. I've got all that stuff on a website now that I can give to people if they're interested in working on this stuff. It's pretty necessary for some of these bugs. But I think the combination of these two will fix hardware VLANs, and I'll fix up TSO as well. I've done some testing on that, but it's broken in the VLAN case still. Then there's a couple easy bugs I found. I'll fix these if nobody else is interested in doing it. Wake on LAN, this is just a matter of moving the power management flags around correctly. There's somebody in Bugzilla that has a proposed patch. It needs some tweaks. We need to solve this holistically, why and where we're setting these flags. I think, just like a handful of concentrated hours will get that bug fixed. And then there's a patch for adding LED management back to this driver. I haven't looked at the patch for that. It came in the past month or so, but it might be ready to go. On IXGBE, I've just tried to do a couple trivial cleanups. Most of them were like, I'm reading the driver and making changes to E1000. So if I saw something, I would run it by ERJ at Intel or whatever. But I also improved the device strings here for the same reason. We just want to know when we're getting PRs, what the card is, and that helps us fix bugs. I'm trying to unify the TXRX in these drivers. There's one for EM class devices. There's one for IGB class devices, and there's one for IXGBE. They're all fairly similar. The descriptor format between IGB and IXGBE is somewhat similar. It's quite different for the previous generations before that. So it's not like you can't necessarily copy everything and consolidate it, but there is a lot of crossover here. And I'm just trying to keep those things synchronized and easier to read if you're transitioning between the drivers. Then there's what I'm calling hard bugs. We don't have TX AIM support. The way transmission works in iflib is completely different than before. I've looked pretty deeply at this problem, and I have some thoughts on it that I'll talk about in the next slide, but I actually don't know what to do here. I'm not sure how this should work. And then I've done testing with the RX AIM, and I don't like it. It doesn't, there's knees where the performance just goes to, bad situations versus the status quo of just having a fixed ITR. So we can't enable this by default right now, and I actually would not recommend enabling that until we figure out how to do it correctly. I don't know when I'll find time to work on that, but this is pretty important. Then iflib as a framework, there are some things we need to fix through here. So there's documentation on how to write a driver in this NextBSD wiki. We need to just go grab the content from there, do some improvement, and turn it into man pages. I think that would be the best course. I'll commit to doing that. I don't know when. It's another time thing. If anybody else wants to do it, any of the things I've described to, just feel free to ping me, and I'd be more than happy to give pointers or participate in reviews or whatever. Then I was working on a Realtek driver for this 2.5 gig chipset. This is difficult for kind of unfortunate reasons. We don't have data sheets from Realtek, and they're extremely reluctant to give those out. Even as, I asked if the foundation could serve as the NDA signer and all that kind of stuff, and they're still hesitant to do it. Then I found out Kevlo, who's a FreeBSD committer, is also an OpenBSD committer, and wrote this driver called RGE that is running on Net and OpenBSD. It might be a better course of action to just use that driver, because this hardware is finicky and the documentation is not available. So at least we could team up with these other BSDs and get bug fixes going between them. I'm not sure if I'll continue this project. I switched over to the E1000 stuff after I found that out, just because it seemed more important. Then Peter Grehan has support for Intel's IGC. This is a 2.5 gig part. It's extremely similar to IGB, so there'll be a lot of crossover there for bug fixes and improvements and things like that. I don't know when this will start showing up on hardware, but it seems like this will be a common driver going forward on at least client platforms, if not embedded devices and stuff like that. Then there's a few hard bugs. This is what I was hinting to earlier. So the primary problem in iflib that I see right now is we combined the MSIX interrupt vectors for transmission and receive. There's good reasons to do this. Like you don't have an unlimited number of these vectors on common platforms, and say you have a bunch of NIC ports and a bunch of NVMe drives and a bunch of cores, it's plausible that you'll run out of queues and that kind of thing. So Intel's guidance is let's use a combined handler. It seems reasonable. The only thing that needs to, that happened here is it's extremely hard to reason about when you rearm these gratuitous TX interrupts. I've looked at this pretty hard for, like a number of days, and I couldn't figure it out. That's more a limitation of myself than like a unfeasibility of this bug. I'm new to some of this stuff and I'm trying to figure it out in my spare time. I'd love to work with somebody on this and see if we can make that better. My belief is UDP performance will go up quite a bit once we fix this. The commentary over this is just we're arming TX interrupts up to the ITR value, and we really shouldn't need to do that. Like if things are working as intended, we should be really not. We're pumping interrupts based on the availability of work. That's the design model of the iflib data path. So the expectation would be you'd have like, on a 10 gig card, maybe like 1,000 interrupts a second or whatever, instead of 30,000 with the current ITR per queue. Then this VLAN bridge offload interaction, I don't have a great handle on this yet. This has come in from Grehan as well. I think what he's saying is we just need to move some of the capability flags around. Like we probably need to disable offloads when you add a bridge. I think some of the other NICs do this correctly, like CXGBE manages all this stuff correctly. You also have to do like promiscuous flag management and stuff like that. I haven't even looked at this yet, but that's pretty important for our firewall users and that kind of thing, virtualization users. So that's the entirety of my talk. I'm just going to keep whittling away at this stuff. More than happy to share the workload with other people or learn from people if you know more about this than me. That's pretty much it. Any questions?
I think actually we're going to move on to the next one to try to keep us going. So next up we have Arka from Dell, who's going to talk about open channel SSD. So you ready, Arka?
Yeah.
Okay, go for it.
Is my screen visible to all?
Yep.
Yeah. Thanks, John. And so a brief introduction. My name is Arka Sharma, and I have been working in Dell for the last 2 years. And I joined the Iceland project last 6 months. And along with my teammates on this project, Amit and Ashutosh, both are present in this call. And our presentation is regarding the POC that we did before joining in Iceland. And our goal was to learn more about FreeBSD. and it is basically the basically a POC of open channel SSD. And our work is we took reference from the Light NVM project, which is the open channel SSD implementation in Linux. So that's it, and let us start. I'll cover few basic things regarding SSDs. So and then we'll proceed with the POC that we have done. So maybe many of you might be already familiar with this. So this is on the left hand side, we basically have a basic block diagram of an SSD, and the main component will be a host interface logic. So for example, it could be NVMe, it could be SATA, it could be SAS also. And in case of NVMe, it directly connects to PCI. So and then in the SSD controller, we typically have a processor which will be mostly a real-time processor, maybe Cortex R or RISC-V or other something like that. And we also have RAM for caching purpose, and we also have RAM for basically the computation which is done inside the SSDs, as well as the map, L2P map, what we store, which we'll cover on the next slide. And then we'll have a flash interface with which the flash chips will be connected. So in the diagram here, we have two channels here. So these two channels are capable of transferring data independently and parallelly. And in each of these two channels, what we see here is two flash packages are connected, right? Now, on a single channel at any given time, only one flash package data transfer can happen. But once that data transfer is complete, then internally when the flash module is running its internal command, then this channel becomes free, and then we can use this concurrently, right? On the right hand side, we have typically internal diagram of a flash chip, and what we have here is chip is divided into dies, and these two dies are independently programmable and readable also. So I can use commands simultaneously, as long as the data, as we can see here, is that we have cache register. When the data is there in the cache register, and we can issue the NAND specific command, right? So these two can happen parallelly. So for example, in die 0, we have plane 0 and plane 1, and plane 0 and plane 1 can have a flash program command simultaneously, or we can read simultaneously. And so this is called plane interleaving. And if we say, let's say if we have something like flash package 1 is doing a program, and that time flash package 2 is getting the data in its own internal cache register. So typically this technique is called chip interleaving. It depends from one literature to another, but typically the chip interleaving and plane interleaving is used. So our next slide is about characteristics as well as the limitations of flash. That in the previous slide, we have seen that flash is divided into pages, right? So pages pages, many pages creates a block, and like with multiple blocks, we have a plane. Or rather, we should say that a flash chip is divided into dies, and the die is divided into plane, and the plane is divided into blocks, which indeed divided into pages. And the pages are basically the unit of read and write command, flash read and write. And we cannot overwrite the page unless this page is erased. And erase again has to be done on block granularity, right? And flash blocks typically will have a limited number of erase that we can perform on them. And typically the single level SLC flash will have higher erase cycles compared to MLC, which is like a multi-level cell, like 2-bit we can store in a single cell. And in those pages, typically the count will be somewhere ranging in thousands, and which will be even in case of TLC, which is a 3-bit per cell, it will be even lesser, somewhere around multiple of hundreds, right? That we could perform erase on them, right? And because of that, the lifetime obviously is, in case of TLC it is less, in case of MLC it is little bit more, and SLC is has more lifetime. Okay, and all these blocks this lifetime is in a way define the lifetime of SSDs, right? So typically towards the end of life, the data that we read from the SSDs, we can get more frequent errors and all. We can get program failure, and this kind of failures we can see if the SSD approaches its EOL. So to address these concerns, so typically some sort of log structure FTL is maintained. So FTL is a software which does the flash translation, which is running in the SSD that we have seen earlier, right? So in the SSD that the processor and what we've seen, the RAM and the internal component that we've seen, typically running the host interface, the host HIL commands as well as the FTLs, right? So FTL typically will be like something implements like log structure, something similar to the log structure file system, right? So it will divide the blocks, and some of the block it will mark them as log blocks. So these log blocks will take incoming writes, okay? And we divide the address space, the entire SSD address space, into logical address space, which is visible to the host, and the physical address space, which is visible to the NAND. And the physical address space is something like the address forms based on the flash geometry that we have seen in the flash internal diagram, right? So FTL typically map the logical address to physical address, and it will also maintain the log structure system, right? So it will out of all the blocks that it has, so it will reserve some blocks as log blocks, and these log blocks will take incoming writes, okay? And if there is any overwrite, okay, and then in the L2P map, right? So where it is logical to physical map, it will update the mapping, right? So say a given page is given LPN is mapped to a given PPN, right? And if there is an overwrite came from the host on that LPN, and obviously that data has to go in one of the log blocks. So in that log block's address will be updated in the L2P map. So as we can see that, so after the once a log block is full, it will marked as a data block, and over the time, as more overwrites are coming from the host, some of the pages in the block will go stale, and after a certain point we need to perform a garbage collection in order to reclaim the block, right? So we will copy the valid pages from those victim block for garbage collection, and we copy from a newly allocated destination block for garbage collection, okay? And also there is something like over the time we also want to perform the erase operation in such a way that it doesn't happen that certain blocks get more erase compared to others. So we want to distribute the erase in a kind of uniform manner. This technique is called wear leveling. So there are a few shortcomings are there with traditional SSDs, which are addressed. I think one of the Warner's paper, which he has addressed this tail latency problem, where the NDA solution is proposed, and also we have this paper where actually the light NVM solution is proposed, right? I'll quickly go over these problems, right? So as we have seen, all the FTL operation is happening within the SSD, and host has absolutely no control on that, right? Or it is not even aware there is underlying translation, okay? And we have also seen that that log structure file system we have seen, right? And there are also many applications out there which already implements log structure fashion, right? And also file system also will have something similar to that. Now what happens is, if we have multiple log structure systems stacked onto each other, then for one layer, the upper layer's metadata is lower layer's data. But in case of SSD, since the host has no control, we might be like using more overrides and leading to garbage collection. And also garbage collection, when garbage collection happens, it also impacts the performance of the SSDs, because garbage collection involves finding out the victim blocks and then copying the valid pages. First of all, determining the valid pages, then copying the valid pages. It is quite a intensive task which Werner has addressed using in his paper. So for these concerns, basically the main concern here is that host not having any control on any of the data placement. So the decision is taken in this approach, the light NVM approach. The idea here is let us divide the responsibilities, right? So in the currently we have all the data placement, media management, which include the error detection and error recovery, and the mapping and IO scheduling. All the things are managed inside the SSDs. So here what we decide to do is that some of the responsibilities we want to move it in the host side, while some of the responsibilities we also want to maintain in the device side. Now host will be aware of the L2P mapping, and since the host is aware of the L2P mapping, it also has to be aware of the physical layout of the NAND, right? And henceforth we need something to expose the underlying NAND format, the NAND hierarchy, including its channels, chips, the dies, the blocks, the entire hierarchy we need to expose to the host, right? And so that host could take that address information, and it can have FTL responsibilities inside the host, right? That is all the open channel SSD is all about. So open channel SSD also comes with the specification that I mentioned in my previous slide, which talks about the physical page interface, right? So it introduced something called vector IO, where we can in different pages we can perform one shot IO, be it read or write. Typically, I had one slide regarding showing how the striping is performed. So typically the target is created by using parallel unit. Parallel unit is basically the chips what we have seen in earlier slides. I have also one diagram showing in one of the slides later. Okay, this is the one. So this PU is basically, it is the OCSSD specs terminology for chip that we have seen in slide 2. So a user can create a target, OCSSD target, using multiple PUs. Okay, and once we do that, so the FTL layer will create the stripe so that it can take advantage of the multiple channel. And if the target is spanning across 2 channels, then we could have we could utilize that parallelism. And in case if the if the target is built using the PUs on a single channel, then we could only take advantage of the interleaving. But how in both the cases, the FTL will attempt to make a best effort to perform to take advantage of the concurrency or underlying concurrency and the parallelism, depending on your target configuration. So we have so in our POC we have used the KEMU. We created we downloaded that KEMU, that OCSSD enabled KEMU, and we used FreeBSD 12.1, and there we implemented this POC, right? So our POC largely similar to the light NVM that we have in Linux, but obviously being the IO interfaces are different and the BIOs are a little different compared to FreeBSD and Linux, and so those changes are there. So this is typically the stack that we have inserted our layer. So we have introduced 2 layers. One is light NVM and one is PBLK. So the PBLK is the pluggable FTL layer. So if we want, we can implement other FTL algorithms and we can plug into the light NVM. The rest of the stack remains same. We made minor changes in the NVMe to accommodate the vector commands. And this is a little bit detailed diagram. So typically this is the light NVM layer. So it sits in the same level as NVD. And it will create a disk interface, which will interface with geom. And while you create a target, like I said, we give the PUs that we want to create the target with, and we also mention what sort of FTL we want to have on it, right? So typically we currently have only one implemented, it's PBLK. So the geom will call the strategy, and it will be intercepted by this disk interface, and then it will forward to our PBLK, and this PBLK where our FTL logic will run. So it will involve lookup. It will involve if there is any bad block, then it encounter any bad block, it will be remapped. All the FTL responsibilities will be performed in the PBLK, including GC. And once it resolved the physical address, it will pass this call to our NVM core or light NVM, and which in turn will call the existing NVMe driver that we have. We just added this light NVM to incorporate the vector commands. And then this part largely the same, that done interface, it will NVM done, and then it will call PBLK done. And from there we'll have the BIO done. And so I would like to give a quick overview of the module that we have in the PBLK. So in PBLK we have a cache. The cache size is 256 slots, and each slot is currently holding 4K data. And for any write command, the data will go to the cache, and we have a writer thread scheduled, and that K thread will pick up the filled up slot from the cache, and it will send it to it will basically do a lookup and then send it to the NVM core, and basically send it to the NAND. So we maintain the L2P metadata in 3 places. One is in the RAM, and in 2 places in the NAND we maintain. So for each block, we reserve the last 40 pages as the L2P map. It is basically a hash map, or associative array, I should say. And also when we write pages, so mostly all flash vendors will provide some spare area for each pages. So we'll also write the LPN in those spare area. So the idea here is that if a block, and also in most of the cases, especially the MLC and TLC NAND, they allow the pages to be written in a block sequentially. So I cannot write block n+1 before I write block n. So that's why I cannot write the last 40 pages without filling the block. So in that case, like let's say one block is half filled, and we need to we face a shutdown, be it normal shutdown or abrupt shutdown. And since we have in that block, since we have the LPN information in the spare area, in the spare, we could scan the block and rebuild the map, right, when the system is booting up. So obviously this will increase the time to some extent, right? So let's go to the next. And this is how the device, that NAND geometry looks like, and it is basically the thing that I was talking about earlier. So we have 2 channels which are independently, it can be multiple channels actually. So suppose let's consider this use case. So we have 2 channels here, 0, 1, 2, 3, let's number them, and 4, 5, 6, 7, right? And I can choose to create a OCSSD target with only one parallel unit. In that case, obviously there will be no striping. I can create 2 parallel unit. In that case, there will be striping with interleaving. I can create 4. In that case, only interleaving is possible. Or I could create with all 8. Or I could also have something like this, like 0, 1 and 4, 5. So in that case also we have interleaving as well as channel parallelism. So this is how the address is divided, and each address is divided with a logical. So actually, if you see the OCSSD spec, the terminology is kind of misleading here. So this offset is basically the, even though they call it logical block, it is basically a page offset inside a block. The chunk is basically the block ID inside a parallel unit, and parallel unit is basically the parallel unit in a channel, and group is basically the channel. Okay, so this is the format of the PPA. So in each, so we have seen in our current NVMe implementation, we typically give the PRP, which is the buffer descriptor, and in we also provide the start LBA and number of LBA. So here it will be, the command will be vector command, vector read or write, and buffer descriptor PRP remains the same, and number of blocks also remains the same, but the start LBA here, instead of one single LBA, it will be an array of PPAs. Okay, so future work is basically we could not complete the garbage collection path, and that is what we want to do. And then we need to do a performance analysis with the traditional NVMe SSDs. And we also thought about having FTL as a geom class. I'm not sure how practical is this, but it is kind of like we thought of. And then we also thought of having this FTL to move in user space and try to see if it is possible to interface with user space NVMe drivers and not. A few open bugs are there, and one of them is basically that that cache, some pointer in the cache, some index in the cache we are facing. That bug is basically, it could be the problem with the KEMU also. I'm not sure that that index, when we are printing, when we are basically facing that inconsistency, we are printing that index value in the telnet, and whatever the value we are getting, and in the GDB stub, when you are examining that value, those two values are different, and we are always seeing a consistent difference. So this is the current status, and there are a few good lessons that we learned. That is basically, obviously, with the, we got familiarization with the FreeBSD, and we got more comfortable with the kernel debugging and topics like geom and all. So I think that's all that I had, and I have attached a few attached a video, and I don't have time to play
Yeah,
it.
I think we'll not be able to do the video today, but maybe if you have a set of your slides you can share with me, I could probably post a link to it on the wiki that folks can see if you have a version you can share publicly.
Yeah, sure.
Okay. Well,
Thanks.
thank you very
Thanks,
much.
and sorry for overstretching it a little.
That's okay. So thanks, Arka. So next up, my goodness, check the schedule. Next up, we have Charlie to talk about GNU Radio. Are you ready, Charlie?
I am ready. So, yeah. So hello, everyone. Yes, I'm Charlie. That's my FreeBSD login there. Kind of a rookie committer, but I've been doing a lot of ports work, mostly on the desktop side of things, and a little bit on the ham radio side of things as well. So yeah, welcome to the conference room. I've got some, although I've got some equipment lined up here. Here's a software-defined radio, the Hack RF, and we got an antenna, and we've got this handy talkie, this handheld radio. We're not going to be able to use any of it today, unfortunately, because what we are going to talk about, which is the GNU radio port, it did not finish building in time for this little presentation. So unfortunately, we will not be able to see some of the stuff in action and power the radio on, but I guess in this case we will just kind of explain a little bit of just some of the challenges, some of the pitfalls, and maybe if there are any budding ports contributors out there who might want to pick up some ports, or interested otherwise in picking up some ports, just something, a little case study of just how to do things, some pitfalls and best practices. So I'm going to go ahead and share my screen here to the correct window. And there we go. As long as it shows up. There we go. So welcome to the Cinnamon desktop environment on FreeBSD. I also maintain that as part of the desktop team and the GNOME team. That's besides the point. But here's a little, so this is my my personal GitLab. I put up the work in progress port, updating GNU Radio to 3.9.1.0. That's the latest version from upstream. The current version in ports, as you can see here, that's 3.8.1.0. That's a little old. The age is not so much the issue as the long list of dependencies and the mess that it was. I'm currently in dark mode, so it might be a little hard to see for all of you. I apologize for that, but I'm a dark mode person, so that's, you have to deal with it. But really, you know, when you're going to update a port, you know, like you always, especially when you're picking one up that you really haven't touched before or either haven't touched for quite a while, you definitely want to do an audit of all your all the dependencies that are that you're specifying or has specified in this case, and it's specified quite a lot. And after this little you know, this whole process of updating this port, there were quite a few dependencies that were just completely irrelevant now. For example, I will highlight why was the Guile 1. Guile 1 was still specified in GNU Radio 3.8 when that dependency probably disappeared long ago. In fact, if you even tried to install what's currently in ports right now and you have something that uses Guile 2, guess what? That Guile 2 stuff is gone. That Guile 2, like PKG will say, do you also want to uninstall everything that depends on Guile 2? So that's an issue. Someone actually on the upstream project reported an issue that they actually needed to build the bleeding edge Git version of GNU Radio because they tried to install the one from ports, which is pre-built, and it actually uninstalled GNOME on them. So, you know, audit your dependencies often, especially if you haven't touched them in a while. So we cleaned this up a lot. GNU Radio in the past used Python 2. That's long gone as well. We got rid of Python 2 in the ports repository for the most part, except for a couple of items. But yeah, so right now GNU Radio completely uses Python 3. All Python 3 components, even the old GNU Radio Companion, which is the GTK graphical user interface for it, that's optional even. Even that one had migrated from PyGTK2 all the way to PyGObject 3, which uses GTK3. So that's good. And what else do we have? We also cleaned up a lot of these CMake arguments. So GNU Radio uses CMake as its build driver, and it's a little, their CMake lists behaves rather erratically, for lack of a better phrase. They actually enable everything by default, and you actually have to disable the whole enable default path that they have you go on in order to make it behave itself. And then so now we can specify exactly what we want to enable and what we don't want to enable. And yeah, so WX widgets, that dependency had not been there for a while either. So that's gone. And then I'm probably gonna have to continue to clean up this libstrip part. And there's some options. Yeah, so the options we cleaned up. We now just have the docs option, which just generates the Doxygen documentation. What else do we have? We have UHD. I have to go down here. There we go. Yeah, so we just have docs, and we're going to optionalize the two GUIs, which is the GRC, the GNU Radio Companion, and the Q5 GUI. They're going to be options, not enabled by default in case someone wants to run it headless, which you can totally run this headless. There's a little testing framework that you can enable. And then we've always had the UHD option, which is just another radio library. that for certain hardware radios out there. And then we also have the 0MQ as an option for, I'm not exactly sure what that does, but we can see about that later. So there are the options. We doing a lot of this cleanup here with making sure all the proper dependencies are the proper options. And yeah, update the dist info, some patch cleanups as well. And then we're not going to load this diff because, yeah, the P list is long and you don't want to see that. So that's the what I have so far for this port. This will go up on Fabricator at some point. And I'll also send out a further call for testing on some mailing list, probably the BSD ham one, but maybe even the ports mailing list as well, for anyone who might want to try it out, or who might be a radio or wireless hacking inclined. They might want to try it out. Go ahead and try it out. The one thing that I do have on Fabricator in support of it is, so one of its main dependencies is libvolk or dvol/volk. That's when it get updated 2.5.0. They actually just released it like a couple days ago. It's actually ready to go as is, apparently, according to my my ports mentors and Yuri, who's a fellow ham radio project member. So if you're going to test out the GNU radio port, when I put it up somewhere, that's not this GitLab instance, you will also need to import this libvolk update, because they're kind of meant to run together, so to speak. What else is there? So yeah, that's so so really the only thing I have left to do on this port here, before we do the whole call for testing, we're going to flavorize the two the two graphical user interfaces. So if I scroll back down here, if I can do so, there we go. So we are going to flavorize the GRC and the Q5 options, so that when you once the package builders build everything, you'll actually be able to see 3 different ports, 3 different packages depending on what you want. You'll have the regular GNU radio package, which will just be everything that you can that you need to run it headless. And then the GRC flavor, which is just that, plus the GNU Radio Companion user interface, aka the GTK interface. And then we'll have the GNU Radio Q5 flavor, which is just that, except change out the GTK interface with the Q5 interface. So they have these options here. And what's also kind of annoying about having to offer it like this is that it's kind of like how we do the Git port. You know, like, so you have the Git port with the regular full feature Git, and then we have Git Lite, we have Git Tiny, and then we have a couple others, but it's all from the same code base. Very much going to be the same deal here with GNU Radio, especially since how they architected the build is that you have to build everything from the top level directory, and you can't just build each individual component yourself. Or by itself for that matter. So that's just something annoying, and something that, that's why we're going to flavorize it that way. So yeah, that's really all I have when it comes to this work in progress of the radio port. And really just, I guess, wrap things up, just look out for the call for testing when it comes out, hopefully later this week, maybe over the weekend. And when that does, if any of you have your amateur radio license, yeah, this is a great way to exercise your privileges. And if any of you don't have your amateur radio license, if you're in the US or have some way of obtaining a US mailing address, we are having a remote testing session, a fully remote testing session for US amateur radio licenses on Sunday afternoon, 1600 hours Eastern time. I will be there as one of the hosts, one of the volunteer examiner hosts. Even though it says Southeast Linux Fest exam, we are co-branding it officially as the Southeast Linux Fest and FreeBSD Developer Summit remote testing session. I will post that. I'll post that link somewhere, I think in the chat, and then I think John or whoever else can get that over to elsewhere as well. but I'll get that here. That's the link if anyone wants to register for the session. And then once you get your license the next week, you can go ahead and exercise your privileges on frequencies that you didn't have access to before, which is how you can use the handy-talkie or the other radio. So yeah, that's all I've got. So thanks everyone for watching, and yeah, look out for the call for testing.
Cool, thanks, Charlie. Up next, we have Cyril, sorry. Here's to talk about RunJ experiments.
Hello, can you guys see my presentation?
Yes, perfect.
Okay, great. So hi, I'm Cyril. I am a co-op student working for the FreeBSD Foundation. So today I'm just going to talk about what I'm currently working on during my co-op term. So a little bit of context so I can explain the motivation behind what I'm doing. Containers, a container is OS level virtualization. So think like Docker, and on Linux, they've got containers. I think they're just called containers. And on FreeBSD, what we have are jails. And this is often described as like Troot, but better. So we've got containers across all different kinds of systems. And so, of course, there is this open container initiative that has a specification, a spec, that will standardize these containers, how they're used, basically, with container runtimes. So I put this quote here that I just took off the OCI website that explains kind of like what their spec standardizes. And the important part is the end. At this point, the OCI runtime bundle would be run by an OCI runtime. So what I've been working on is this OCI runtime. It is like a program that you give it a runtime bundle and it runs it as a container. So for example, on FreeBSD, it would run the runtime bundle as a jail. So first on Linux, what do they have? They have a program called RISC-V made by the people at Docker. So this is just a program that is compatible, fully compliant with the OCI runtime spec. And it's got support for Linux specific things too, like namespaces and C groups. And the reason for that is actually because those things are in the OCI specification. So I've attached a picture here of the Linux specific page from the specification. So they have platform specific configuration options in the spec. So they have it for Linux and Windows and Solaris, but they don't have one for FreeBSD yet. So what is it like on FreeBSD? So on FreeBSD, we kind of have this project called RunJ, which is supposed to be a RunC equivalent. It's currently in development by Samuel Karp, and so it doesn't support everything yet. But adding the remaining general OCI specification should be straightforward. But the more interesting thing is that the spec doesn't have dedicated FreeBSD configuration options. So if we only followed the OCI spec, then it could be kind of limited because there might be some functionality that FreeBSD supports that isn't in the specification. So should we design a specification that is specific for FreeBSD? Or maybe the question would be better worded as, if we were to design it, what kind of things would we add to this spec? And so that is kind of the question that I've been thinking about currently. That's what I'm doing. And so I'll give an example here. So you remember how I mentioned 2 slides back that RunC has support for C groups. And so that is like, that on Linux is what you can use to limit the resources that a container can use. So for example, you can limit memory usage or CPU usage of a container. And on FreeBSD, we actually have something that we can use to also do that. We have something called raccount, which you can use to easily set resource limits per jail. And although like the OCI specification has R limits, in the configuration that's like per process. So if we could use our account instead, that could give us more power, more configuration. And so that was one of the things that I was doing, was thinking about adding R control. So R control is the program that you use to set the limits of the R account limits. And so I kind of did like an experimental add R control to RJ and see how that works out. It was pretty simple. I just put a screenshot here. I know this is super out of context, so it doesn't really mean much, but there's the screenshot there. And so you can see that you can specify what R account resource you want to limit and the limit. And the interesting thing is it doesn't stop there. There are like other questions come out of this, such as like, do we want to support all R account limits? Because some of them don't actually make sense to apply per jail. Some limits would only make sense like per user or per process or something. So does it make sense to say in the spec that all our account limits will be supported, or are we going to define only a subset of our account limits that will be supported? For example, I can't think of anything off the top of my head. Sorry, but yeah. So you can see this work is mostly thinking about questions, not much programming, but more like thinking and researching and discussing with other people. So that is just like a little slice of what I've been doing. That is the end of my presentation.
Cool. Thank you very much, Cyril. I think up next we have, if I can find the right tab. Up next we have Yang, who also is an intern with the FreeBSD Foundation, who's going to talk about installer prototyping.
Okay, everything showing up properly?
Yep.
All right, great. Hello. Oh yeah, my name is Yang, and I'm also very similar to Cyril's situation. I'm a co-op intern at the FreeBSD Foundation, and I've been working on an installer that uses like, I'll just show you a screenshot. It uses a browser form as input. And so I'm basing it off of Ryan Muller's sort of work on the prototype. I've been just adding additional parts to that. And so the motivation for something like this is that the current FreeBSD installer, which is BSD install, uses like a terminal dialog interface, and it's somewhat unwieldy. And I see people talking about there's issues with it, asking some like strange questions that maybe not be familiar to new users to FreeBSD. And so this is sort of a way to try to make an installer that is friendlier and also more full-featured and easy to use. And so having these browser UI elements sort of help with that, because they're very familiar and also accessible. They have very standard sort of navigation even without the mouse. And so I've been working on, here's another screenshot, adding some very early on work to stuff like the keyboard configuration, which can dynamically change, and you can type it to see if it works down there. And so, while I am here, I'm doing some other thinking about installers and about their usability. And one issue I came up with for BSD install is that you would enter in something like your disks and your partitions and your network, and then it would sort of stop you, and you had to sit there for 5 minutes, and it's unpacking and installing everything, and then it goes back and prompts you to ask for the users and stuff. And so for the idea for this one is that instead of doing that, you would do all the configuration work first, and then it would do the install. And sort of in the middle, what I would want to have is a sort of config file that the installer front end would write to, and then the actual installing program would just read out the config file. And the benefit of that would be that we can have simpler installations that use scripts, and we can also plug in other sort of installation front ends easily. And BSD install does have a config for installing automatically, but it's very sort of what's the word for it? It's very free flowing, where you configure your disks, but then the rest of it is basically just a the big old shell script that you have to type yourself to set everything up. And so as you can probably tell, the work is very early on in initial stuff. I've just mostly been thinking about how I want to structure the front end of it. I've been doing a bit of JavaScript work to get these sort of network configuration stuff going. And here's the link for the Ryan Muller's early work on it. I forgot to put my own repository there, but I've been basing it off of that. And one of the things I've been thinking about was how to sort of limit my use of JavaScript in this, because it seems sort of to me that's sort of if the more I use it, the more complicated everything becomes and unmaintainable. So I've been thinking a lot about the big picture stuff there. And yeah, so it would be very helpful to me if anyone has any sort of thoughts on the installers in general and what their opinions are, what their experiences are. It would be really helpful if you contact me. I did not put my email on this, but it's yzong@freebsdfoundation.org. That is all. That's
cool. Thank you very much. Up next, we have Christoph, who's volunteered to talk about PF because he hasn't done that enough today.
Yeah, well, sorry, I'll try to keep it short. There is some ongoing work in PF. There are three main points that I wanted to cover. The first is that there's ongoing work to change the way PF configuration is done, specifically the ioctl layer. It used to be that PF just shared structure definitions between what it used in the kernel and how it got configured. That got split up not too long ago as part of the counter work, but that's still not ideal because anytime you try to add new features, you want to change a structure definition and you get into ABI issues. So I've converted a number of ioctl commands to use NV lists. I'm not going to expand on the advantages of NV lists here, but it does mean that we can add fields without breaking user space. So that's ongoing. As part of that, I introduced libpfctl, which wraps these NV list interactions into functions. There's a port for that library because I don't want the base system to have to give library stability guarantees, because then we're straight back into the problem where we can't extend the API easily. There is a port. The expectation is that ports that interact with PF programmatically, so ports that use the ioctl interface, they should look at migrating to the library because sooner or later I'm going to remove the old ioctls. Well, from 14, they will of course remain in 13 and 12, but the old style is going to go away at some point. Not all commands have been converted so far. I expect to convert them as we add features to things. So this is a long-term project, but it's ongoing. That is part of work that is sponsored by Netgate, by the way. As is the next topic, I'm working on trying to make PF use DummyNet. So right now for packet queuing, packet scheduling, we have AltQ, which is old and not enabled by default and doesn't work on all hardware for complicated and boring driver API reasons. The intention, the hope is that we can get PF to just use DummyNet, and then we will have one packet queuing scheduling framework in the kernel used by both IPFW and PF. That's very much ongoing work, but it's ongoing. I hope to make some real progress on that soon. Final topic is work that's sponsored by Modirum, and that is porting PF syn cookie support. A while ago, OpenBSD took FreeBSD syn cookie support from the network stack itself, and they moved it into PF. Now I'm looking at porting that work from OpenBSD SPF to FreeBSD SPF. Just today, I managed to get that to the point where at least the basic test case worked. There's quite a lot of work left to be done, but well, that too is ongoing. That's basically everything I had. I see one question. Did I change DummyNet to support more than 4 gigabits per second? No, I did not.
Okay, thanks, Christoph. Up next, we have Konstantin to talk about like various topics. AMD64 boot to kernel handoff, AFI runtime, and kernel address layout randomization. Interesting.
Thank you, John. Do you hear me?
Yes, I do.
Okay, I hope everybody else also hear me. So basically, let me share the do you see slides now?
Yep.
Okay, so basically, this is not a talk about the work in progress. Actually, this is a talk about work that is currently not in progress, and will try to explain why. I realized that it should be explained because today I wanted to make two absolutely identical notes during two talks. One was about bootloader, another was during the mentioning of KSLR. We have an ongoing problem in the boundary between AMD64 bootloader and kernel, and it is important enough that it affects actually a lot of different parts of the system. Basically, of course, it affects the low-level kernel code and PMAP bootstrap that creates initial kernel page tables, but also it affects, for instance, runtime services for YEFI. It affects the possibility of implementation of kexec. It also affects this ever important thing like KLSR. So what is it? How kernel starts on AMD64? We put kernel text and data initialized part of kernel at the kernel load address, physical address. It is currently defined as 2 megabytes. After that, the mode of the CPU is set to 64-bit, and we create initial pre-boot page tables which map each 1 gig of low memory to all 1 gig entries in the kernel virtual address space. Basically, the low 1 gigabyte of physical memory is identically mapped to all terabytes of kernel virtual address space. And then we jump to low core, which create initial boot stack, calls hammer time, and then we bootstrap them up and have a more or less running kernel configuration. So the big problem there is that we put the kernel at 2 megabytes of physical memory. This is practically this works now, but theoretically it is incompatible with many configurations. For instance, this memory might be claimed by YEFI for runtime services. For kexec, the same memory should be used by the ongoing kernel. We can't just replace it, so we would need to implement something like a trampoline that double copies the incoming kernel. It should be put somewhere, then trampoline is run, then trampoline override existing kernel with the new kernel. Similarly, it cannot be used if anything like KSLR is implemented, because we put kernel at fixed physical address that then have fixed virtual mapping. So this stuff is actually is quite central despite being very low level. And the first time I look at it is when I implemented, when the initial support for FE booting was implemented, but at that time, again another trampoline was done, which double copied kernel somewhere, then trampoline copied kernel at the required location in physical memory. Similar problem was with implementation of EFRT. Again, if we override any runtime reserved memory, we can't have runtime services at the kernel runtime. So how to solve it? First, kernel need to be made relocatable, and second, somebody would need to do this relocation. It is more complex relocation that currently done for the kernel. We just add some addends in not too many places, but we would need a much more advanced kernel relocator. And it is not clear where this relocator should be put in the boot code itself or in the kernel. Also, additional detail that resulting kernel still needs to be linked for compiled and linked for the kernel memory model, which only allows to use the upper 2 gigabytes of virtual address space for text. And why it is now the question why it is not done yet, because I cannot imagine a way to implement it without changing the interface between bootloader and kernel. We need to change both how kernel put in memory and how it is relocated, and probably change the format of the kernel file on disk itself. So whatever we do, it probably will be a flag day for all users. They would need to have a new loader to boot a new kernel. So it is a problem, and this problem stops me from doing this change in any nearest time. I'm open to suggestions what to do and how to ease these transitions, but I think we will need to do something about it, and especially when a EFI system become more important, and we will want to provide FE runtimes on more machines where the requirements of the BIOS will be conflicting with our existing memory map. That's mostly it.
Okay, thanks, Konstantin. Let's see, we might have, we have a couple of questions. Did you want to take a stab at those? The first one, someone has asked, which EFI runtime services does FreeBSD use?
Well, first, practically most important is probably EFI runtime variables editor that allows you to set up the booting. But we have other things like you can use the FE interface to the smooth timekeeping and so on. So we do use them. Second question, is it possible to have two loaders installed? I think practically it means that one loader would need to support both kind of kernels, old and new. But it is, I didn't so hard about it, but it is something that would still require some attention and the configuration changes from user. I don't know, really. Can you have a new loader that can load new and old kernels? Yes, that's basically what I'm saying, but as I said, it would still not that easy or painless as could be hoped for. No more, John, no more questions from me. So I'm
Okay.
done.
Thank you, Konstantin. So our last talk for today is Ed Mast, who's going to be talking about updates to LLDB.
All right, so this presentation was put together by the Moritz Systems folks who were not able to join. So I'll just present the status update and where we're gonna go next. So this is just about Moritz, and the foundation funded Moritz to do the work on LLDB. Some background about LLDB. I think folks generally know this. We've been using LLDB and FreeBSD for quite a while now, and it's increasingly usable as a debugger. When we first added it, it was quite experimental and had a lot of rough edges. And for userland at this point, it's in pretty good shape now. This is the work that we've had Moritz take on. So let's see here. The first big task is when LLDB was originally created, it came from Apple. It was a Darwin slash iOS slash Mac OS debugger, and the design was designed with that in mind, and implemented as a inherently client-server debugging model. So in its sort of primary reference target, it would always run the debug target under a debug server and communicate with it. And the debugger front end basically communicated with the debug stub to do all of its actions. And one of the interesting things about that is that it gives you it means that your local and remote debugging experience is identical. You're not going to have cases where you're debugging a process on the same machine in the same having the debugged process running in the same process as the debugger is not going to be different from doing a remote debug session. But the original port of LLDB functionality to Linux didn't use that model. And on Linux, it ran the debug in the same process. And when that work was ported to FreeBSD as well, it inherited that design. So Linux and FreeBSD originally operated that way. So using in-process debugging for debugging on the same device, or remote debugging if you have some other debug stub that you can connect to. And the Linux LLDB developers implemented two-process client-server debugging some time ago, and FreeBSD was left as basically the only target that was still using the in-process space. So, originally it was a shared Linux and FreeBSD implementation, and was maintained by Linux people as well. But once they completed the work to move the Linux target support to use the client-server implementation, we were left as the only consumers of the old and undesired approach. And so Moritz implemented FreeBSD support for the client-server model. That was last year. This year, they've added significantly improved support for ARM64 on FreeBSD, and sort of did a best effort approach of bringing up support for all of the other architectures. non-x86, non-ARM support in LLDB for FreeBSD and for Linux for that matter is not sort of necessarily all that well tested or well used. So the migrating to the client server model and updating it, has as a side effect gotten some more test coverage and some more review on those architectures. But really the target support of interest is really x86 and ARM. And so as it says at the bottom here, the old single process model has now been completely removed, and only the client server model remains. GDB has support for following either the forked child or parent, and LLDB lacked that originally, and so that's supported now. One future addition would be to have the ability to follow both. So basically, have the debug session split into two upon a fork, and be able to choose what you do with the parent or child. But at least now you can continue debugging in the parent or switch and debug in the child. A lot of work done on core dumps, and this resulted in some improvements in FreeBSD kernel as well for having. So as a result of this work, there's kernel support for creating a userland core dump on demand, which is basically a kernel support for what G-Core provides. And one of the benefits this has is that the same code gets used to create core dumps on demand as is used for creating core dumps in response to a signal. So it means that there's the core dump that's written is going to be consistent between the two. One of the big things that came out of this work, though also from what Moritz did, is that the tests are much improved for core dumps at this point. Lots of bug fixes, and the test suite on LLDB for a long time, even on Linux, was somewhat flaky, or at least some small portion of the tests were somewhat flaky. The tests are at a point now where they're either consistently passing, or at least are identified and known as flaky or marked as expected failures. And then what we're looking at investigating for future work is bringing kernel debugging support. So right now, LLDB doesn't have any ability to debug either kernel core files or live kernel debugging. And so we're evaluating that as the next steps. So I think, John, that's what I have for that.
Okay. Well, thank you to all of our work in progress session speakers today for your talks. And thank you for all of our attendees for being on our thing on our Dev Summit today. Clearly, I'm in need of some lunch. We will see you all tomorrow for our third and final day of the Developer Summit. Folks who want to hang out in the hallway track, you're welcome to do so. I'll probably be there after I grab some lunch. Maybe if Warner's around, we'll talk about process stuff. But otherwise, I'll see you all tomorrow morning. So thanks all.